respected dignitaries, distinguished faculty members, industry leaders, researchers, doctors, students, ladies and gentlemen, and my dear friends, a very warm good afternoon and welcome to the Indian Institute of Science. Sharira Madhyam Khalu Dharma Sadhanam. It means the body is the primary instrument through which we fulfill every purpose in life. Friends, with this thought in mind, before we begin, permit me a story, one that belongs to this very soil. In 1893, on a ship sailing from Yokohama to Vancouver, two remarkable Indians met, Jamshedji Tata, the industrialist, and Swami Vivekananda, the monk. Tata spoke of his dream, a research institute for India. Swami Vivekananda replied that science, pursued in the spirit of service, would be India's greatest strength. From that conversation on the deck of a ship was born the Indian Institute of Science. More than a century later, that founding idea, science in the service of society, is alive in this hall today. From developing technologies from aerospace, energy, artificial intelligence, and quantum science to advancing healthcare, IISc has consistently transformed fundamental research into solutions that serve society. Today's program is a reflection of that enduring mission. A research from an IISc laboratory steps out to serve millions of Indians living with diabetes. Before we proceed, every auspicious beginning starts with gratitude and divine blessings. Let us invoke the grace of the Almighty to guide our thoughts and efforts as we begin today's program. May I now request the invocation song. India is home to nearly 100 million people living with diabetes, making it one of our greatest public health challenges. The need today is not just better treatment, but affordable, accessible, and technology-driven solutions that reach every individual. That is the significance of today's program, bringing together medicine, engineering, AI, industry, and research to transform diabetes care through innovation that is scalable, indigenous, and impactful. Dr. APJ Kalam once said, "Science is a beautiful gift to humanity. We should use it to improve the lives of people." That thought perfectly captures the spirit of today's program. On behalf of Professor Radhakant Padi, Vishvasys Technologies, the organizing committee, and the Indian Institute of Science, I extend a heartfelt welcome to our distinguished guests, speakers, industry partners, and all participants. May today's discussion inspire innovations that make diabetes care more affordable, accessible, and impactful for millions. Before we proceed, I would also like to acknowledge Ms. Anushri and Muskan, who are standing here beautifully dressed. They are fourth semester engineering students specializing in biotechnology from MS Ramaiah Institute, who will be assisting me on stage throughout today's program. Thank you both for your support. With that, let me embark on this journey of innovation and collaboration. It is now time for the first address of the afternoon. We are honored to have Professor G. Ananta Suresh with us. Before we invite him to deliver his talk, may I request Ms. Anushri to kindly read his biography. Over to you, Anu.
Thank you, ma'am. A very warm welcome to everyone present here. To initiate our first session, I am deeply honored to introduce our first distinguished speaker of the day, Professor G.K. Anant Suresh. Professor Anand Suresh is a HEG professor at IISc. His highly impactful research focuses on intersecting mechanical engineering with healthcare, specifically in the field of digital podiatry. He is the forefront of developing adaptive smart footwear technologies designed for diabetic patients experiencing neuropathy and peripheral loss of sensation. Today, he will be sharing his expertise on digital podiatry and dynamic offloading footwear, demonstrating how precision engineering can be translated into highly effective, affordable preventive care. Please join me in extending a warm welcome to Professor G.K. Anand Suresh.
Thank you for the kind introduction and good afternoon. I thank Professor Padi for inviting me here. He does not take no for anything, so I have to come here. Right? It's a pleasure to be here. It's a nice gathering to share what we have been doing. I'm told that I have 10 minutes, so it will be a very fast talk. There is a stall outside where you can find the details. And here are the people I worked with for the last 6 years actually. The doctors are here at the bottom, Dr. Pawan Belahalli, Dr. Sanjay Sharma, Dr. Paul Graham, he's in Australia, the other two in Bengaluru here. They're planning another big event in diabetes, they could not be here today. All my students, and most of them are out of IISc already. Raghavendra Kattakade, PhD student who is here at the stall, are here. And I'm going to, of course, I have to acknowledge the people who funded this work, Rajiv Gandhi Institute of Health Sciences, BIRAC DBT, BEST Cluster, and Stridate is an incubated company based on our technology, and they also have the stall outside. And this work was done at IISc and KIER, Carnatic Institute of Endocrinology and Research. And since about digital podiatry, I should say that few years before IISc conceived its idea of having its own hospital and a medical school, we had a big plan for digital health just before the pandemic actually. At that time, with all the thoughts that we had and the people that we were interacting with, we brought out a special issue on digital health in the Journal of IISc, and it's available Springer. You can look at 27 articles that are there, edited by Professor Vijay Chandru. Now our hospital is going to be digital, so much of what we had discussed will be part of our hospital and the medical school. So what I'm going to talk about in the few minutes that I have now is a neglected complication of diabetes mellitus. So there are 4 complications, major complications: cardiovascular, retinopathy, retinopathy. 4th one is diabetic neuropathy. If you look at the underside of the foot, which is called the plantar region, that's where a lot of pressure, all our weight goes there. And when you have blood glucose under control or over a long time you have a diabetic condition, there's a chance that, actually there's a big chance that says 25-35 people develop diabetic foot ulcer because the nerves will be affected. You have peripheral neuropathy. This is one of the major factors for developing diabetic foot ulcer called DFU. And 50% of them also get infected. And if we don't take care, here is a disturbing statistic that every 20 seconds, that is before I finish this sentence, there is a foot amputation somewhere in the world. It is that bad, every 20 seconds. That's for a world, for the world. Now if you think about India, it will be much worse because we have, as we just heard, 100 million officially people diagnosed with diabetes, but it could be a factor of 2 or 3 than that, right? And that's a bad news, but the good news is that 80% of these foot amputations can be prevented if they are diagnosed early. That was a hope for us. So as engineers, what could we do along with podiatrists? Another bad news that in India or in the rest of the world also, there are very few specializers in podiatry, podiatric surgeons who take care. A lot of orthopedics will turn to podiatric surgery, but real podiatric trained ones are very few all over the world. In India, if I look at it, it's 1:1 million. We have one doctor who can treat and then 1 million patients. So if that is the situation, how can we find a solution? That's when we thought of digital podiatry. Can we have a digital hospital? But this is for the digital foot hospital. All we need is 10 feet by 10 feet area where 5 tests are done. In fact, you can see that we have set up these podiatric clinics, one at KER for a long time, for more than actually 1.5 years now. There's one in Chikbalapur District Hospital, one in IISc Health Center. These tests are done under 20 minutes, and then we give a report to the patient. So this is how it looks. So there is a foot mat where you walk, your plantar pressure is taken. With a smartphone, the foot photograph is taken, and then there is a neurotouch instrument to look at peripheral neuropathy, and there is ABI-TBI, ratio of the pressure in the arm to the ankle, arm to the big toe, that ABI-TBI. All those tests are done, and temperature also can be taken. With all those tests, we can, well, this is DPOC, we call it Digital Podiatric Clinic. We can do the triaging. So low risk, medium risk, high risk. This is where we have decision support algorithms to do this, because at this DPOC, there is no need for a doctor to be there. In fact, my podiatric clinicians, collaborators say that somebody who is 10th standard pass is enough to be trained to be at this clinic. That's why we thought, we want to reach, million feet with this or more. We can do this triaging, and then, if they're medium risk, there is some little bit debriding or something can be done, or if they need, we can use corrective footwear. I'll talk more about that. But high risk, of course, they have to go to a foot clinic. There are a lot of foot clinics. They can go there and get treated. And a report will be given to the patient, automatically generated after go through this. This is all the technology can give. The social impact of this is that it's affordable and accessible. That's very important for something like this. And also, we can reduce incidence of DFU, diabetic foot ulcers, and thereby reduce the foot amputation. And this just to give you the idea of the DPOC that was there in KER over a period of time. We had more than 6,500 patients. You see the things. When they were screened, they did not know. 76% of them had peripheral neuropathy. They lose the sensation in the plantar region of the foot. So if there is high pressure and some injury, they wouldn't even feel the pain. They come too late to the clinic. 76%. Peripheral arterial disease, another one, that is 11%, both together 7%. Diabetic foot ulcer also 30%. 1 in 3 people who randomly done, right? So that is very high, and that's what we see everywhere. There's lack of awareness also about this complication, and there are a lot of things that are being done here, and Stride Aid and other places that we have collaborations with. But what I'll talk about is the mechanics. I'm a mechanical engineer. One is therapeutic footwear, other is digital twin for the foot. State of the art, I would say, of course there are experts here, is not fully satisfactory, because it does what is called static offloading. When you go there, you stand on something, your pressure will be taken, it can be contoured like it is shown there, or some pocketing out will be there to offload. The region where the high pressure, you offload. But then question arises in your mind quickly, all our weight has to go somewhere. If we offload in a portion of the foot, other parts will have the higher pressure. Then they develop the ulcer there, they call them transfer ulcer. So what we need is actually dynamic offloading. That is, you should be able to sense where the high pressure is, offload there, it goes somewhere else as you walk, it should do. And that can be done with sensors, actuators, as this illustration is shown from the literature. You can have a lot of sensors in the plantar region, and then you can have actuators. Whenever sensor detects the pressure is high, you offload it immediately. Then you need sensors, actuators, microprocessor, and a battery. So without all that, what you have come up with is a mechanical solution where these arches, when the force acts on them, when the force exceeds at a limit, they automatically offload, as you see in the simulation. And we have an array of these arches. This is not just a foam or something that have special properties. Any material we can design, and an array of them, like this arch, you can see it's a high-speed video enlarged. It loses contact by itself and then comes back up. For this is bistable, it will come back up. So what we have, as you can see in this animation, these arches arranged in the plantar region that can be customized to each individual, and it just goes like a midsole, and it will look like a normal footwear. And this customization has a lot of nonlinear mechanics that I'm not going to go through, but we can look at the plantar pressure of a person and design the arches in different regions, and they can be, of course, initial prototype 3D printed, but now they're vacuum cast. They don't cost much. Each one of those arch blocks costs only a few rupees, actually. So it will be accessible and affordable as well. So we have done the test at KER at the beginning. We saw that in different regions of the plantar region, the foot, there was decrease in pressure. 210 kilopascal is the limit, and we were able to bring it down everywhere. It's quite simple. This was a 3D printed one, but now what we have is actually vacuum cast. You can see the left side we have without our intervention. The right side is with the midsole. You can see the scale, the blue to red, the 0 to whatever, 150 to 210 kilopascal is the same scale for both. Red regions are less. Of course, you see that big toe region has a little red that was not there without it. That means it will be customized. So we can see how much we can bring down. You can try that footwear outside. And next thing is that how do we design it for people? We want to customize it. So we are making a digital twin of everybody's foot. When I started studying foot as a mechanical engineer, I cannot but admire. Foot is a mechanical marvel. It's really wonderful with 26 bones. You may wonder, hand has 26 bones, foot has 26 bones. Why? What hand does to the motion, foot does to the force, is what I learned now. With so many joints and 100 plus tendons, more than 20 muscles, and the soft tissue all around it, it's a really marvel. And we are doing that in our model, computational model. We do the simulation. Our idea is for everybody's foot, taking from the plantar pressure and a photo of the foot. We have parameterized model. We adjust the parameters and come up with your own digital twin with which we can actually design the footwear if necessary and have prognosis also. If you wear the footwear, what will happen after some time and what other intervention is needed. It's a big optimization problem. I'm not going to go into details of that, but I'll just show you one solution. One of the doctors himself, over here on the left side, experimental data. Right side is what we have simulated with his foot model. They're not exact, but that's good enough. That's a normal pressure that is perpendicular to the foot. What we get out of computation models also is shear component. Shear is one that actually causes more damage to the skin than normal. So it's a additional thing. There are no sensors that measure shear. We want to work on that as well. That also we get out of that. Everywhere is really close, not exact, but this is good enough for designing footwear. So the main points to conclude, we are making the foot screening accessible and also affordable using digital podiatric clinics, and we can intervene early and prevent DFUs, diabetic foot ulcers, and manage them is already there, and increasing awareness, that's also very important. So I had said DPOX and offloading footwear, digital foot twin, I covered that. There is more AI-based decision support software, and there is a chatbot. So after 20 minutes you undergo test, you will have a lot of questions. So the chatbot answers. Right now it is in English, but the regional language also will be done soon. There is a digital foot registry, diabetic foot registry also we are working on. There are a lot of registries around the country, but consolidated one. So that's what we have. So I would say get tested at DPOC today. Thank you very much.
We'll take up all the questions towards the end of the program. Okay, thank you.
Thank you, Professor, for your insightful and inspiring address. Your journey exemplifies how research, innovation, and entrepreneurship can come together to create meaningful societal impact. Moving forward, it is our distinct privilege to present a keynote address delivered via a video by our next speaker. Professor Navkant Bhatt serves as the Dean of the Division of Interdisciplinary Science and is a professor at the Center of Nanoscience and Engineering at the IISc. His pioneering research spans nanoelectronics, electrochemical biosciences, and lab-on-chip devices. Driven by a committed mission to render healthcare both affordable and accessible, Professor Bhatt's work seamlessly bridges the gap between deep tech research and real-world clinical applications. Today, he will be sharing his insights on diagnosis at doorsteps for diabetes and non-communicable diseases, illustrating how the engineering for portable miniature laboratories can transform health screening in rural and undeserved communities. I request everyone to direct your attention to the screen for Professor Navkant Bhatt's address.
Very good afternoon. I've titled my talk as Diagnostics at Your Doorsteps. This is essentially a culmination of the research that we began in my group almost 2 decades ago. which is now creating impact on the ground through IISc incubated startup Pachod Healthcare. Vinay Kumar, who is my former PhD student, now heading Pachod Healthcare. So let me get started with this presentation. Very briefly, it's a very short time we have, just about 10 minutes. So just to capture in one slide, we started this research on biosensors with an intent to really address the healthcare divide through point-of-care diagnostic devices. That's when I started working on biosensors, collaborating with clinicians, eventually through multiple generations of PhD students, culminating with Vinay Kumar, doing some exceptional work in this area. By 2015, we had many IPs that we had created, so we thought it would be prudent to start, translation of this work, and then we collaborated very extensively with our clinical partners. And, we went through multiple generations of products, listening to the customer feedback. And today I'm proud to say that this product is a series of products rather, are used in 17 states across India. By range of users, as we will see a little later. I will not go deep into research in given this shortage of time, but I want to give you a big picture on what it is, right? So if you look at evolution of pathology, starting from very early 1900s, where pathology lab was a chemistry lab, doing a lot of titrations in the lab with body fluids, then, of course, with the advent of immunoassays, what we have today is any modern diagnostic pathology lab. Autoanalyzers, which are very bulky equipment, nonetheless, they give very accurate, measurement of range of biomarkers, be it in blood, urine, and saliva, or what have you, right? But the question that we were asking, if you were to really bridge what one calls a healthcare device, we have already bridged the digital divide, more or less. I come from the electronics and semiconductors technology, which is very relevant in that context. We were asking, how can we leverage nanotechnology in healthcare to, really address this issue? And as enunciated by World Health Organization, we really had to take care of accessibility, availability, and affordability. That's where point-of-care wearable devices become extremely important. And indeed, through our research, through chemistry, biology, electronics, all aspects, looking at that, we came up with the first generation of product, which we called Lab on Palm. And of course, it has gone through, multiple iterations, and, what we have today, we call them Anupath Nano series of product, which are extremely miniaturized products. Indeed, a platform product, as I will show you, which can be adapted to sort of any diagnostic test that you want. So again, our focus was not infectious diseases, but instead it was non-communicable diseases. And particularly diabetes, which is the focus of today's workshop that Professor Padi has organized. These numbers are staggering. This is what I was looking at even early 2000 when I began, researching in this area. And it's not just diabetes. If you look at the whole spectrum of NCDs, right, even things like the anemia, right, which should have been a solved problem by now, but it continues to be a mass casualty event, which you can say unfolding in slow motion, right? Still you have more than 2 billion people affected, not just in India. Of course, India has a huge burden of, anemia, but even, you would have imagined that these are not the problems of the developer, but even over there, this is indeed a problem of malnutrition and the resulting, anemia burden thereof. So, and hence there are many other complications of diabetes that one can do. And when you have diabetes and anemia, it is double whammy, right? It's even worse, for the individual, right, in terms of managing that. So through our focused research in this area, we were able to come up with technologies and IPs over a range of biomarkers: hemoglobin, glycated hemoglobin, which is HbA1c, which is gold standard for diabetes, serum albumin, glycated albumin, blood glucose, of course, microalbuminuria, urine creatinine, ACR, of course. And even beyond that, during COVID pandemic, we were able to adopt COVID-19 antibody and antigen test on the same platform. And there are many more that we are looking at right now. Some are in early R&D stage, but some are really very mature, manufacturable products used by people in the field right now. And more importantly, it's a technology which is formidable in the sense that it's a protected technology with, more than 30 international patents issued across 8 countries. And the focus really is to, end what we call India's 87% dependency on imported medical devices. This is a staggering dependency and number that we have. And hence the idea was to really establish an indigenous sovereignty and build this point of care technology, not just for India, but of course rest of the world as well, global south and elsewhere. And what we have, when I say diagnostics at doorsteps, it's not a concept or an R&D in a university, right? It's actually, something which one can touch, feel and use today, right? I'll show you some examples just to indicate the platform. So this is, of course, what we call a nanoglucometer. We claim that this is world's fastest and least painful. The sample size is even less than what Roche uses, and extremely accurate, right? Even better than what Roche provides, for instance. And that's why we see a huge traction in users switching from international brands to Pachot brand. Hemoglobin, as I said, this is, again, you see the same platform, same electrochemical sensing technology. Of course, the strips are different, the chemistry is different. And this is a very unique technology. Again, we have many technology for hemoglobin sensing, and we don't stop at one, but we continue to innovate there. And again, we say that this is world's fastest and least painful hemoglobin results we can get in just a couple of seconds, actually, less than 5 seconds, right? And what we also have is what we call, combo or 2-in-1 or even 3-in-1 or multi-in-1 offer, right? So again, this is technology that we have now, which can do both blood glucose and HbA1c, right? This is extremely important for diabetes management. Again, I would say that this is perhaps the only device which does HbA1c, which is based on strips. This is another unique device technology, which is blood glucose and hemoglobin. Extremely important, for example, women and child health, especially during pregnancy. You have not only the burden of anemia there and also gestational diabetes, right? So there's a lot of gynecologists using this device right now, right? Just to show you some comparison, right, where we stand, right, in terms of even the best international standards. In HbA1c, you have DC Advantage from Siemens, which is a tabletop device. This is how it looks. And you have Abbott and Infineon, which is again a tabletop device. I mean, compare that with what we have here in Anupat Nano A1C device, right? Extremely portable, extremely efficient. Same with the hemoglobin. I'm just showing one more example here. HemoQ, it's a Swedish company now acquired by Danaher, which is of course a global medtech giant. This is the hemoglobin device based on cartridges, right? Of course, it's they call it handheld, but still half a kg, right? These are the devices. But compare and contrast that with the nano hemoglobin device that we have. And what is very important, as I said, it's not really sitting in the lab, right? It has moved beyond the lab, beyond the company, into the field, right? These are some examples of hospitals which are using this very extensively, not just in OPD, but also in ward and ICUs and even emergencies, right? I mean, Ramaya, which is next door, for example, has completely switched to Pachod Anupat technology. And what is most rewarding for us is really, one of the very well-known diabetologists in India, Dr. Mohan's, clinic, right, clinical network across the country. They have decided to adopt this. In fact, we are in the final stages of finalizing an MOU with partnership with Dr. Mohan's clinics, when it will be deployed across more than 60 centers across the country. And advanced discussions with Tata 1mg, where they want to showcase these products and technology as preferred platform on their online portal. But what is important for us is really going beyond these clinics and hospitals. Government, of course, lot of programs under National Health Mission, right? We call it B2G segment, right? More than 200 Namma clinics in Bangalore are using this, right? And very recently, Government of Karnataka Health Department has just finalized, and the delivery is also half completed. More than 1 crore tests through their public health intervention program, right? Similarly, Government of Maharashtra has started using. Advanced discussions with Government of Rajasthan, Odisha, and Haryana and Telangana, and so on and so forth. But what is even more rewarding for us is what we call a B2N segment, right? That is NGOs. We have now partnerships with a whole range of NGOs across the country, right? And this is really, I would say even going beyond the doorsteps, right? This is really reaching remote corners of India, where it is even difficult to imagine setting up a pathology lab, right? So that is a kind of impact that is being created, right? So what is the outlook then? Right, India is actually staring at an import crisis of close to 6,000 crore vulnerability, right? Close to 90% of it is actually imported, right? And through this IISc technology, the focus is to squarely address this crisis, right? Not just for India, as I said, for the rest of the world as well, right? So I'll stop there. Thank you very much. Dr. Vinay Kumar is right there. I could not be there in person. So if you have any questions, please get in touch with Vinay. Thank you and bye.
Although Professor Navkan Bhatt couldn't join us in person today, we are immensely grateful to him for preparing this insightful address. Your work beautifully demonstrates the transformative potential of nanotechnology and engineering in addressing real-world healthcare challenges. Our next speaker for the day is Dr. Siddharth Jhunjhunwala, an associate professor in the Department of Bioengineering at IISc, where he heads the Immunoengineering Lab. His research focuses on particle immune cell interactions, neutrophil dynamics, and the behavior of innate immune cell in diabetes. His talk today will cover his comprehensive research on the longitudinal tracking of diabetic patient cohorts in India, detailing how this empirical data enables the formulation of targeted therapeutic interventions. Ladies and gentlemen, please welcome Dr. Siddharth Jhunjhunwala.
Thank you. Really good afternoon to all of you. Glad you're here. Today I'm going to talk to you about one piece of research in my laboratory. Actually, it's not research, it's more of a public health process that we have tried to set up in collaboration with the IISc Center for Public Health at Indian Institute of Science. And I'm going to talk to you about a few results from our initial studies. And this is to set up a longitudinal cohort. Let's first go about trying to understand why such studies are necessary. So when we think about the human health, right, we think about somebody going from childhood all the way to geriatric care. And in diabetes, when we look at type 2 diabetes specifically, and so we're going to look at only that, the quite big question is, who is going to become diabetic and when are they going to become diabetic? Both of which we have not been able to answer, and I don't know if we'll be able to answer that anytime soon, but can we help with predicting who might become diabetic and when they might become diabetic, right? So it's now very clear that there's age-related changes, and this is world over. So as you cross 60, 65, your incidence of cardiovascular disease and diabetes increases dramatically. The risk of it increases dramatically. But in India, we also face another challenge, and this is not just in India, it's in many other countries, but it's definitely true for India, which is very early on. We're talking about ages starting from about 40, sometimes even as early as 35. People start to develop symptoms that are pre-diabetic and diabetic-like, and eventually type 2 diabetes. And these could be genetic or lifestyle related. That's the suggestion. But what exactly drives this remains unclear, and our studies are focused towards trying to understand this. How do we do this? There's a lot of work that's going on in animal models, including in my lab, but that doesn't fully explain what might happen in humans. And for this, most of the world has moved towards longitudinal cohorts. So to give you an idea, these are the two questions that almost everybody is trying to answer. Sorry, the last part of the slide is cut off, but what increases the propensity for diabetes? So who will become, and what are the early predictors for diabetic development? This is the question that most people are trying to answer. And there's no need to ask this question as to why do we need to answer this question. I think there's enough reasons. I'm not going to belabor that point here. But this is the sort of cohort studies that exists across the world. These are some of the studies, and I've just made a small list, right? And what you need to focus on here is when it started. So this part, almost all of these studies, I don't know if you can see my slide, but when it started, somewhere between the 90s to mid 2000s to late 2010 maybe. But if you ask whether such cohort studies are available in India, the answer is limited to none. Right, and there's one recent one called Landmark study in 2021, fantastic study, but it's primarily enrolling people with diabetes only. So it follows people after they develop diabetes. There's a CAR study, which is fantastic again for cardiovascular risk, and there's some data there for diabetes, but not enough. And there are many others in hospital-based settings, but they're very small. Right? So the basic problems are none of them really collect extensive data. There are about 5 or 10 different parameters as we think about it. And it's focused primarily on people who already have diabetes because they're hospital-based studies, not the general population. And there are problems in doing this sort of study with the general population because in India it's not very common for us to go get health checkups done. It's becoming more common, but it's still not very common to get it annually or once in 2 years or so on. Right? So this data doesn't exist. And that was the thing that we were trying to address. And so this is the study. Basically, we have set up a longitudinal cohort in IISc as a pilot program to show that we can collect this data, and then we want to then try to expand it to a larger cohort. The pilot studies began in 2021 with about 25 individuals, very, very small. We are looking to actually look at studies. So if you look at studies elsewhere in the world, all of these are between 50,000 to 200,000 and so on and so forth. So it's really large numbers. We've started with 25 in 2021, and that was a seed for getting this funding from the IISc Center for Public Health at IISc. And now we have 200 people enrolled in our study, and I'm going to present some of that data. Right. So the data for this looks like the following. So we had at baseline 227 people enrolled within IISc campus. So they had to be associated with IISc in some form. The age group was 35 onwards. So students are not involved in the study, as in are not enrolled in the study. They're involved in analyzing the data, but not enrolled in the study. And we have some follow-ups, and every 6 months we try to collect this data. And right now we're at follow-up round 4. So that's about 2 years after they have enrolled in the study. And as every other study, there's always some dropouts, various reasons why people don't want to continue, even though we perform the test for free for them, and that costs about $4,000 to $5,000 to us, and that's what the funding was required for, right? So this is the main slide, and I know it's text-based, but I'm going to try to read it out for you in some way. So if our baseline population is 227, and if you think of this as a sample from the Indian population, it's not perfect, but it's still a sample. 40% are normoglycemic. That is, only 40% would be considered healthy in their blood sugar level in the 35 to 65 age range in the IISc campus. This is, of course, not a representative sample. It's some sample of people who are volunteers. Pre-diabetes is about 31%, 30%. that's actually the same as what you would look at elsewhere in the country. So we're not very different from the rest of the country. Many other studies that we measure this show about 25 to 30% is a pre-diabetic rate at this age group. Many studies start at 18, and 18 to 30 you'll see almost nobody is pre-diabetic, but 35 onwards the numbers start increasing. Diabetes is about 27%, 27.8. The adult population, the diabetic rate is considered to be 12% or 13% in India, and that's again 18 years onwards. But if you start looking at 35 years onwards, there are more people who are diabetic. So 1/4, in fact, if most of this audience is about 35 and above, 1/4 of you are likely to have diabetes. You probably know you have diabetes. But that's the part that's funny. Even in IISc, there were 35%, 1/3 of that did not know that they had diabetes. They did not know. And it was our study, that was the first time they'd done a health checkup, and they found out that they had diabetes. I'm not talking about pre-diabetes, I'm not talking about anything else, I'm talking about diabetes. HbA1c values above 6.5%, where they really need to get on medication immediately. In fact, it's usually about 7.5 in the unaware group. Even among the aware, and again, mind you, this is within IISc campus, which has, the population has access to healthcare in every form possible. Under treatment is very high, that's nice, 90%. Some people choose not to take the treatment, that's perfectly fine, that happens in any sort of society. But among the treated, only 40% achieved control, which is less than 7% HbA1c, that's the world standard, right? And that is a serious problem. These are the two serious problems in India. Why are there 1/3 of the population that's unaware that they're diabetic, and then why are 60% uncontrolled, right? Of course, the number of diabetic also is a serious problem, but that's a separate issue. And so this is the reason why we think that analyzing and understanding who will develop diabetes becomes very important. So in IISc, we could do this occupational profile, but for the lack of time, I'm not going to go into this. I can answer questions later. But what is different between the unaware and aware is something I wanted to highlight, because that's sort of a takeaway point from this study. It's still too early to make it a policy change, but it's still something interesting. Unaware people, so that's this side, aware is this side, tend to consume more sugar in their coffee and tea. Very simple thing. They're adding 1 to 3 teaspoons or 4 to 6 teaspoons per serving of their beverage, versus many diabetics end up removing sugar from coffee and tea. And that's always a good sign, because you will see in our other data that the aware diabetics are generally having lesser HbA1c, better blood control, and so on, right? So a simple thing could be, as a policy change, reduce the amount of sugar you add to your coffee and tea. The same sort of continues across fruit juices and sweets. So this is fruit juice. Many people would not add, if they're diabetic, they would not add any added sugar, whereas most who are unaware but diabetic end up adding a lot more sugar. And of course, unaware, the healthy individuals also add more sugar. So the unaware diabetic are behaving like healthy individuals when they should be behaving like diabetic individuals. And in fact, the most interesting thing was almost everybody who are unaware diabetic consumed at least one sweet a week, right? Whereas many of the diabetics were starting to give up sweets. And so basically, the amount of sugar that they're taking up is very high in the unaware diabetics, and that reducing that can actually control a lot of things. It's a simple change in diet, tough change from a public health perspective, but easy maybe for an individual to try out. So that's the take home. Take home is basically that diabetes awareness and control is poor, even in a controlled, highly educated, or at least better educated, better socioeconomic status like IISc. More importantly, the unaware diabetics are the ones who are consuming more sugar, and this raises potential policy implications of, can there be a large policy change in the state health machinery saying consume less sugar in your coffee, tea, consume less sugar in your fruit juices. That might make those differences. Quickly to summarize, to end with acknowledgements, thank you to the IISc Center for Public Health, which funded most of the study, IISc, which is where IISc Center for Public Health is based off, which helped with the seed funding. This initial findings from the study are out as a preprint right now. You can search for it. The work was conducted primarily by Shaina and Abhinav with help from Archana, who is the clinical study coordinator. And we've had help from Professor Pradeep Kaur, who is chair of ICPH, and a few others who were involved in the study. I'll leave you with this slide, and I'm happy to take questions later after when we have time. Thank you.
Thank you, Professor, for the enlightening presentation. Your contribution to immunoengineering and translational biomedical research are truly inspiring and impactful. We now commence our first panel discussion of the day. It is my privilege to introduce our moderator, Dr. Srinivas MK, who currently heads CP Med TBI at Indian Institute of Science, an alumnus of Harvard Kennedy School and Hebrew University. Dr. Srinivas brings about 22 years of healthcare expertise, spanning medical administration, healthcare IT architecture, and enterprise agility. As a strategic business advisor, his work bridges innovation, commercialization, and regulatory standards for medtech startups, advocating for smart aging through advanced technology. Joining him on the panel are our three distinguished panelists. First, Dr. Vinay Chauhan, CEO and Head of R&D Department at Path Shod Healthcare. An alumnus of Indian Institute of Science with a PhD in nanoscience and engineering, Dr. Chauhan is highly decorated innovator, holding 36 international patents, a recipient of the prestigious MIT Technology Review TR35 and the Anjali Machekar Inclusive Innovation Award. He focuses on developing novel point-of-care biosensing technologies to ease the burden of chronic diseases. Next, Professor Radhakant Padi, HAG Professor in the Department of Aerospace Engineering at the Indian Institute of Science, a former scientist at DRDO who earned his PhD from Missouri University of Science and Technology. Professor Padi is renowned for his pioneering work in nonlinear, adaptive, and intelligent control systems. His research significantly advances autonomous systems, guidance navigation, and vital biomedical control applications. Next, we have Professor Dr. Mala Dharmalingam, Director of Bangalore Endocrinology Diabetes Research Center, a foremost authority in endocrine care and former senior professor and head of department at MS Ramaiah Medical College. She has made exceptional contribution to medical research and clinical research with over 210 indexed publications. Her dedication to the field has been recognized with numerous honors, including Dr. B.C. Roy Award. Together, they will be addressing a vital question in the modern healthcare. Can diabetes patient live a carefree life with the help of technology? I invite our moderator, Dr. Srinivas, to guide the discussion. May I have all the panelists on the panel?
Welcome all the panel members. Thank you all for being here. When you look at it, any chronic condition and carefree life don't go together. And diabetes is the worst of it. A sweet in the morning, no, 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 no. Extra lunch in the afternoon, no, 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 no. A bit of rice in the evening, hey, no way. This is how our life is when you are a diabetic, right? From there, who is going to support us? Not the doctors, frankly, because unless you comply how much you eat, how are you taking medicines, how much you are exercising, list of prescriptional things that comes from doctors, and we thank you for that, but still, it's not a carefree life. Then comes the technology. Today we'll understand, both from the medical experts and the technologists, if technology can anyway make the life of a diabetic carefree, and we'll also check out if the doctors concur with that, right? Thank you very much. Thank you. So, my first question is towards you, Ms. Dr. Bala Dharmalingam. It's about pain reduction. The worst part is the tests. Daily you put into that, and in a prick in the morning, then 1 hour, 2 hours before and after and other things. Pain. As it is, disease condition is a pain, and additional pain of diagnostic testing throughout. So my question is, how effectively do continuous glucose monitors eliminate the daily pain of finger prick tests and reduce the mental anxiety of tracking blood sugar?
So thank you very much. At the outset, I would like to say that possibly it's just not diabetics who can't lead carefree life. I don't think anyone should lead life like that, because I have many of my diabetics who don't have a myocardial infarction or a heart attack, while a non-diabetic who's careless can end up with one. So I think today every one of us have to be careful with the kind of attractions all around us and the society not conducive to us to have good health. And coming back to the question, yes, definitely CGM or continuous glucose monitoring has come a long way in not only reducing pain, it also makes life easier for a diabetic, because it's not possible for a patient to prick himself as often as I would want him to as a patient. I would say prick at least once a day or 2 times a day or at least 5 times a week, and he would find it painful. So, and it's a stress. Many of them still have the fear of the needle. So this is something which is just implanted in the skin, and it tests the glucose through the interstitium. And so we also not only have a point, we also have a continuum. So we can understand how the sugar behaves through the day for the next 14 days, even for doctors to get a better idea of where we are. And 100% definitely, it is painless and compared to the prick of the glucometers.
Thank you very much. Now, once the glucose monitoring and is happening, right, and the delivery has to be there, the insulin one monitored and the delivery has to be there. Suppose we are automating the delivery of the insulin. My question to Professor Radhakant Padhi is, to what extent do smart insulin pumps successfully mimic the human pancreas by automatically adjusting insulin levels based on food intake and exercise?
Well, thank you for that. So I've been working on this problem for a while, so can probably a little bit qualified to answer that. The whole idea is, well, we can never mimic the real pancreas. That is the admission that we should always have. Having said that, we can actually very closely mimic that as much as possible. So technology is advancing. In fact, the very basic AI, if you talk about decades earlier, what is called as control theory, feedback control theory. It's actually a basic AI. We talk a sensor, get a data, get a real-time decision. That's a fundamental AI. But now that AI technology has gone quite a bit more advanced in the sense of you can actually compensate for your prediction errors also. Suppose there was a model, there was algorithm was not good. Can you compensate more? That's number one. So then the fundamental problem of this AI-based or control system-based algorithm that I find in all the things, 2-3 things are there. I'll give a little presentation later. One thing is the unknown time delay. So essentially, no matter whatever CGM can do, little faster and accurate and all that, but it never does the blood glucose calculation in real time. Actually, it finds the interstitial fluid, so there is a delay, and that delay you don't know. There can be anywhere between 8 to 20 minutes or something that way. So that delay is sensing delay. What about actuation delay? Now the actuation is you put an insulin pump and the insulin doesn't go to blood again. It goes again interstitial, and that has this monomeric, non-monomeric all sort of forms and all that. So there is again a delay there. So essentially like you are driving a car and then you are looking a scene which was there 10 minutes before, and you are taking some action which will come, your car will react to that 10 minutes later. Now, can you really talk about driving a car like that? It is kind of difficult, basically. Then fundamentally, we are plagued with the idea that who wants to take what kind of food, we don't know. Somebody has to kind of keep on telling the system, because AI, no matter what, cannot predict how much you are going to eat, what you are going to eat 10 minutes later, 15 minutes later. That cannot be done. Only when you eat it, something can be sensed, but that is too late already, basically. So there are certain fundamental drawbacks for which we can never mimic the real pancreas in true sense. But having said that, there are a lot of other technological development as well. In other words, people are still working on implantable pancreas. People are still working on revival of the pancreas. I mean, there is some recent development in China, looks like. So those things, if it comes from the biotech side of the story, then probably our side of the story, giving insulin from outside, will come down, and that may actually react better in some sense. But that is too far away, so we'll wait for that, and then hopefully things will go in that direction. Not because we'll get jobless, but we want to get jobless later. So that is what it's supposed to be. But if it happens like that, nothing like that. But also remember, there are a lot of these reaction things and all that. For example, pancreas, you cannot take some pancreas and put it in some other. Transplant doesn't work. So human transplant also doesn't work. In fact, pancreatic cancer is one of the toughest cancer to crack. Basically, all these things are there. So essentially, we are there. The control theory is quite a bit developed. In fact, we can take care of constraint handling. In other words, the safety critical system we can also talk about. And one good thing about biomedical system is even the actuation or the control update time cycle in minutes. So you can actually do all sort of computation in a mobile phone. So which was earlier not possible is now possible. So there are certain minus things, certain plus things and all that. So taking advantage of all the plus things, we are trying our best to compensate for the model inaccuracy, compensate for time delay, compensate for safety critical system, compensate for variety of other intra-patient variability, intra-patient variability. A little bit, this adaptive, what is called as a Lyapunov, Lyapunov system theory based, stability theory based learning, online learning of adaptive, this AI part of it. So AI augmented optimal control, which is safety critical. So all these things are possible, and we are doing that, by the way. But no matter what, there are certain fundamental issues for which we will not be able to exactly mimic that, but maybe even if we mimic 70-80%, we are done, because nobody talks about high precision control here. It is what is required is robust control. The control should be within a band. So that is why there is a luxury also in that side of the story. So there is hope at the end of the day.
Wonderful. Thank you very much. Now all the diabetics can clap that for the hope given by the Professor Padi. And one more thing, that when we go to the initial days, when we were I used to take my aunts and things for testing. And they used to draw such a huge amount of blood, right? To take, forget diabetes, these people who die of anemia, already we are an anemic country. It used to feel that, each time you would say, they have taken so much blood, they have taken so much blood. Because they don't understand that it's required. But then a revolution came, Patshod, where all the tests that you need, so much of blood to be taken, now is about a drop. Give me a drop, I'll tell you your life story, kind of thing, right? Dr. Chauhan, can we expect carryable diagnostic things because instead of going to the doctors, labs and other things, can we educate our diabetics that they can carry their own diagnostic kit, right? And it will be more carryable and discreetly carryable. Like, when you take the normal glucometer, it's like a setup. You put the setup kit and get, all the setting is done. Through Patshod, can we expect more acceptable and carryable diagnostic sets?
Yeah, actually, if we look the diabetes management, so this is the disease which has the multiple pillar in management. Diagnostic is the one, medicine is other, discipline of the patient is another one, and how's the stress level is very important, If we see, back in 1980s when the first glucometer launched, and in fact it came from academia only, Professor Clark, who developed the first concept of oxygen electron. And now it is the part of every diabetic patient. I am juvenile diabetic from last 24 years, and now of course I carry the insulin pump, I have the Guardian sensor and all. But over the year now, we are in a very exciting time of research, because when we talk about the portability and accuracy, we have those techniques. In fact, in IISc itself, when we were doing this Patshod research, probably it was not 1.5 decade ago was not possible to characterize the materials and what type of material we need. But what we developed from our example of Patshod, and what Professor Bhatt also narrated, that we can compete with world's best in quality. Glucometer, just one example, 99% around we are still importing. And being the #1 diabetic country, into the world. So in India, for our population, it is very much possible now that we have a very portable device. Like Patshod now have the device which dimension is almost like a pen drive type of thing. And when we see the pricking thing, because there was a lot of innovation happen. Earlier, the drop volume was like very big drop required. Now we have 0.4 microliter, it's less than a mosquito bite, So the pain is like minimal invasive. From this era to the science, we are now going close to non-invasive techniques also. This is now the holy grail, that there is no need of prick. And I just want to say that for few tests like hemoglobin and all, Patshod is very close to give the breakthrough of non-invasive biosensor also. So yes, this is very important for the patient that we have the very portable and highly accurate. The only thing, what matter in medical device is the lab grade accuracy, and that give the confidence to the clinicians and patients both. So it is not another digital gadget. You need, Patshod started the full revenue 2 years back, if I talk about the business side, but it took 10 years to do whole the clinical validation. So it need the the great deep science research, and whole is experimental science. There's no much into simulation. You need to do the phase wise, but India is doing, like lot of professors talk about, particularly IISc, the lot of groundbreaking technology. I'm sure are the part of now becoming in India the part of life of the patient, but very soon it will be the part of life around the world from India.
Wonderful. Till now we have been receiving, so soon we'll be serving to the world. Thank you very much. And next comes the emergency alerts. Dr. Mala and Professor Padi, both questions both to you. How reliable are the predictive alerts on smartwatches or any such alert mechanisms in preventing severe hypoglycemia emergencies before they happen?
Definitely the smartwatches are good. I would not say 100%, but definitely around 80% to 90%. But the drawbacks in that is when you're when you're severely hypoglycemic, the ranges may not be very correct. The other things are interference with whether there's any pressure, there's displacement. So, and also there is false alarms can happen, and this may be too much of data for patient, irritability. So there are some drawbacks with the alarm system, but definitely it is good because when we are looking at type 1 diabetes, we are looking at either low sugar or high sugar, both of which are bad. And now we are also going to get ketones in the CGM, which is also going to be very good because this is also going to prevent hospitalization. So it's not just the blood glucose that we are looking at, we are also looking at all of these also in CGM.
Yeah, about the irritability factor, probably she is the better person to answer that. But then there's too much irritability in the night also sometimes, okay. But the question, there are many things that can happen. So no matter, see, all that talking about alert system is based on some sensing. Now, again, no sensor company, no offense to anybody here, including Parsad, but no sensor company can ever tailor it to a very customizable way to every patient. So it can do a mass study, I mean 100, 200, 500,000 patients and all that, then do some sort of a mean value sort of tracking. Then the mean value comes with plus or minus variations as well. Now these variations depend on the patient's chemical condition with the subcutaneous fluid that particular day that you have. That also keeps on changing, right? So this variability factor starts from there. It is how good is that interaction, how good is the data is picked up basically. So that is what is your current value. Now comes to predictive value. Now predictive value is always based on certain model. Now that model also needs to be customized to your body basically. Right? So that is it has to be customized sensing followed by customized prediction. And that is what the world is going towards, something called customized medicine delivery. So that is part of it basically. Similarly, the part of that is customized sensing as well. So what we recommend, and we are actually doing that also, whenever you buy a CGM, fantastic, they have done every sort of thing, whatever possible, and the reliability, error, accuracy, all that has improved over a period of time, but still they cannot make it every patient specific. So you buy a sensor and then talk about some sort of a one-time, two-time calibration during the lifetime. So let's say one sensor lasts for about 2 weeks. So what we are recommending is every week, once a week probably, just take some 5-6 blood sample, something like 15-20 minutes interval over a meal, so that the sensor sees low values, sensor sees also high values, things like that. Then you can actually have a host of corrections that actually came from our artificial pancreas with Dr. Malani some time back. We actually, what we do is we compensate for unknown time delay, we compensate for something called bias for every sensor, and we also compensate for scale factor. So all these, and you can also do higher order. If you can also talk about quadratic term accuracy, also thing. I mean, Dr. Abhishek is there, he must have done quite a bit of work actually. So this is essentially, there are certain characterization of every sensor that you can do. By the way, there is interesting cross-disciplinary things also here. The way we actually compensate for the time delay actually comes by talking to our EC friends actually. I mean the mobile signal delay and all that. No, that is whatever they are doing there. Somehow we have been able to mimic that. So that comes from a very side technology, something that we never imagined actually. Then bias, scale factor, higher acceleration factor, all that is essentially Taylor series some sort of ideas that we regularly do in aerospace. So you can take this multidisciplinary thing and then put it them together. Now it becomes very customized sensing. Now comes the customized prediction, and the prediction is a different ballgame altogether. So we can also talk about there is something called database prediction. So it is blindly, suppose your future data is a linear function of past 3 data. I mean, there is no science for that basically. But if you really talk about compartmental models, this differential equation based model, what you talk about, chemical science people and all that, whatever systematic study of something of rate of change, rate of increase, rate of decrease, then also that depends on particular person. So this, if you really want to do accurate prediction based on that, then the patient has to go through certain protocol, certain procedure. And that procedure that if Dr. Malla remembers, probably we talk about something like 25 blood samples in the morning. And that 25 blood sample, that to IV sample. And then you talk about, as blood insulin prediction, not just blood sugar basically, right? So it's an expensive affair when you really talk about very high degree of prediction. But once you do that, the prediction is fantastic. So you actually do this, if somebody can go through that protocol and things like that, that doesn't have to be repeated every week, that can be repeated every 6 months, 1 year, something like that. But let's say annually, a patient agrees to do that protocol annually once, and then every time you buy a sensor, 4 or 5 finger pricks, something like that you do, then both the things can be done. So your sensor can be very accurate to your body, and then prediction is already customized. And then based on that, you can try improving your database prediction and things like that. You can still keep on kind of customizing all the way. So, but there is effort involved, there is cost involved, there is inconvenience involved.
Yeah.
So that is how it is. But possible, technically possible.
Yeah, so affordable is a relative term in that case.
Well, it's possible. Technology is possible, that's not a problem. But other factors come in, whether you are ready to do this test, whether ready to spend some money, whether ready to do all this, the inconvenience that you talk about. So if you do all that, but even if you don't go for the prediction part of it, still if your sensing bias error is all that is eliminated, then also this irritation, false alarms and all that to a large extent can be avoided.
Wonderful. Thank you very much. Now this question is open to all three. We'll start with Dr. Chauhan. Lifestyle and freedom. I thought about the dietary freedom also. And the question is, do carbohydrate counting apps and smart kitchen skills, these are all over the place these days, allow diabetic patients to enjoy a wider variety of foods without constant fear? From the scanning and sensor part, I would like to start from you.
Yes, very much. I eat everything. So this myth, we should break that, it is good, like particularly I think if in type 1, we are taking the same hormone from outside, which your body is making inside. So insulin is the ideal, medicine. But of course, type 1 usually start very lean body, and but nowadays though, if age grows, if we eat with more freedom, with restriction, we can take carbohydrate also, we can take sweets also. There is no such hard and fast rule. We can do party also. There is no problem. But there should be some eyes on the carbohydrate consumption, because otherwise it will be like a dual diabetes. Even the type 1 developed, there's a lot of research, the insulin resistance, which was mainly for type 2. So if we keep the eyes on, like we don't develop I'm talking about in the context of type 1. And type 1, why? Because they need more freedom. This is the very early childhood diabetes, the whole career and whole life, in front of them. Instead of restricting, we need to educate them. This is very important, and they can eat, they can enjoy the life, and just know to develop the resistance, so that it should not happen if I'm carrying or wearing the insulin pump that, okay, today is the party, just add 10 more unit extra. Of course, it will bring down, but there are the side effects on that, yeah.
Thank you. Professor Padi, your views?
What's the question, by the way? I forgot. Distracted with the guest coming in, so that's why.
So, see, we have the today apps, including which is multi-apps are happening, where the carbohydrate counting happens once you take a click. SugarSight and others also may be able to do that. And then you have the smart kitchen scales, where you know how much you are putting, how much you are eating. Even the Ones who are the six packs people also do the smart kitchen scales and do.
Okay, so what's the question now?
Yeah. Now do they really work? And will they make it?
Yeah, we have some experience to talk about it anyway.
Yeah.
So we actually, Lalit is there, somebody started working. So we actually, in our own app, we have started thinking about it. One thing that people get carried away is the image is good, seeing is believing. Now, image based, because smartphones are capable with hundreds of images, no? Our phones are so good actually, high quality image and all that you can talk about. So we started doing that and burnt our finger actually. So the question is not that your smartphone is not smart, smartphone is always smart. The thinking process of ours is not smart. In other words, suppose you are putting on let's say 2 chapatis you put whichever angle you take the picture, the picture will tell it's 1 chapati only, because it's overlap, right? Then there is a color of the rice which doesn't know whether it is biryani or pulao. It depends actually, right? Depends. So there are a lot of confusion that keeps in. I'm just giving one example, right? If you put dal is dal or sambar. There are so many things that keeps in, and overlapping food, right? Suppose you put compartmental and then this is one, like a thali sort of thing. Then probably somewhat easier. Then you have to calibrate quantity. Then you have to do many things are there. So that becomes a little bit harder for us. I mean, we tried our best, but could not succeed. So what we are doing right now is voice based. So at least let the person talk about it. Now the voice has come in a big way. So all our Sarvam AI and all that, no, Indian voice and all that is come in a big way. And also there are calibrated, there are certified quantities, calorie, and not only calories, the sugar. The sugar quantity and calorie quantity are calibrated for about 250 cooked food item. So most of the time what happens is they will do raw food. This much rice, that much dal, but raw dal, raw rice. You don't know what is the calorie and all that after the cooking process of that. So this has been a very fantastic development from MDRF. Again, thanks to Dr. Mohan and team. They have actually done Indian meal cooked item for about 250 things. We have calibrated or expanded that to some sort of a logic based or common sense based, so some 1,000 things. For example, you take 1 plate of idli, 2 idlis. So one that's equivalent to 130 idli, equivalent to 1 bullet idli. I mean, that kind of thing you can keep on doing that, and then people can come up with some numbers. So we are in the testing process, about 80% accuracy already got something. So there are issues of voice getting wrapped actually, the voice based pronunciation or problem. It turns out that ladies' voice is much more kind of clear compared to the gents' voice. But that's a fun part of the journey. So going forward, what we are planning is voice will be the primary. And even if there is a data, you don't want to kind of throw it out. Multi-data centric diagnostic is always good. So we'll augment that with picture also. Now the pictures help in doctors basically, because if they see a picture, you don't have to explain anything. So that is a voice-based thing. All these AIs also have a problem, that if you tell about what I'm going to eat, but at the end you don't eat. Some residual things are left out, something you don't like is left out, something is not tasty, some very high salt or sugar is left out, salt or chili, not sugar, you left out. So these things should also be counted for minusing. So that can be better done by telling. So my conviction is unless that is primary source should be voice, secondary source should be image. So both will talk about it and then the improvement will be good.
Wonderful.
It's possible basically.
Thank you. Dr. Mala, quick comment on the technologies.
No, I think carb counting is definitely very, very good for type 1 diabetics. Like Dr. Vinay was saying, it right from I have children who are 2 years, 3 years, and you can't tell the mother, don't give him chocolate cake on his birthday or something like that. That is most traumatic for the doctor herself or himself. So carb counting is again very predictive. Supposing you're saying that the child should eat 1 chocolate cake for his birthday, you can predict the carb in that and give a dose of insulin to combat that kind of carb counting, and we do advise it to all our type 1 diabetic children that carb counting is very good, and they should, and in today's pumps you can actually put in that as a bolus and give it to the patient so their sugars never rise. So that is a very, very good thing, I think, for carb counting. We don't do it routinely for type 2 diabetes.
Thank you. The final question, 2 questions will be about now we are slightly carefree and things. Now we are going to travel and sports, right? How do the health devices empower diabetics to participate in high intensity sports?
Well, that's the, how many of you know Wasim Akram? Pakistan cricket player, fast bowler, type 1 diabetes.
Zverev, he type just won his tennis.
Yeah,
just 2 days
possible.
back.
Yes, certainly possible. And in fact, exercise modeling, Abhishek has done something. Abhishek can comment on that. But then essentially exercise modeling is possible because of your heart rate, because of step count, because of many things are sweating, how much you are sweating, all these things you take into account, and in fact body temperature also. So again it's a multi-data centric sort of thing. Actually a part of Vishvasys thesis also talks about exercise modeling and things like that. That is certainly possible, but with a good quality of self-discipline. You cannot do whatever you want, but again the CGM and other things help. In fact I also know another type 1 as a friend, he lives in Bangalore only. Yeah, I don't know whether he's there or not today, he's supposed to come here. But then he actually always puts a CGM and then goes for tracking, goes for wherever it is and takes a little bit of food inside, and whenever he feels down, he can take a little bit. Life can go on, not a problem actually.
Wonderful. So the final question, after that post-final one question will be there. It is about the financial barriers, right? Yes. Since advanced diabetic tech is highly expensive, can we truly say it offers a carefree life? Or if it's only affordable for a small percentage of global population, how it is? How do we define affordability here?
See, when we look the technology advancement, of course, CGM is there, insulin pumps are there, but in country like India, not affordable at all for the general public. We are sitting into metro city Bangalore. We can, wear these. But I always advocate like a old school thinking in diabetes management. We are living into AI era and all that is all good, data driven and all good. But if we can educate with very simple concepts to diabetes population, like what is the role of carb. Of course, into the type 1 diabetes, they want adventure, they want to play intensity game and all. CGM can track, but it is very, I can say hypo is most dangerous in type 1. Hyper still they can survive, but hypo is like, very bad. So affordability in today's context, where India is importing 87%, this is the drug controller data, including majority the diabetes technology. Situation is not really good in India. So that is why we need the indigenous technology, which is affordable and accurate like these MNC giants. And if you look the careful how, many times we feel like, from last at least 3-4 decades, we are using this technology from outside. But either it is Roche, we are using these, glucometers of Roche, but never a major giant innovate the future technology. Roche acquired the AccuCheck. Johnson & Johnson acquired a startup LiveScan. Right, and lot of these technology which today coming from IISc, I'm sure these are the future innovation. Yeah.
One quick comment, see many of these things are actually unaffordable, so indigenous and all that helps anyway. But also remember, because of it, it also prevents complications a lot. The insurance companies have started supporting this initiative. That is many of the Western countries and all that. So if that concept also comes here, that insurance partly covers it and things like that, then the popularity will be much better. And there is, I think this question is also a little bit out of syllabus because panel 2 topics is this. It's a panel 2 is dedicated for that. We should not encroach upon them actually. That way. All right, thank you.
Okay. The final question, what are the... No, just 1 second. Because he has spoke about hyper and hypo. A final question from the both. A quick comment. What are the other tests other than CGM that diabetic patients need to continuously monitor for a more carefree life, and can the technologies deliver it?
Of course, this is taken by Dr. Mala, but I think I've been suggested by ICMR, some of the additional directors, generals and all that you should couple continuous blood pressure measurement. We have been talking a little bit. Yeah. BG and BP are always together, looks like.
So I'll take this opportunity to say that we need to do blood glucose monitoring. That is dependent not on our wish. There are guidelines for that, and your doctor will tell you how often you should do it and at what times of the day. Every 3 monthly, you have to do a glycosylated hemoglobin. And because glycosylated hemoglobin is just a mean, that is why we have CGM. So that is a continuous glucose monitoring. And if it's affordable, definitely a CGM at least once in 3 or 6 months is advisable. Apart from that, once a year to test for all micro and macrovascular complications is a must. A kidney function test, urea creatinine, lipid profile, liver function test, hemoglobin, PCV. These are some very, very important tests that they should do. They should also do an annual ECG. They should do a fundoscopy. And without forgetting the first talk, we have to do a foot evaluation. Most diabetic centers do have a foot evaluation, which is so important because in our country still we have barefoot walking, especially even to temples, which can still cause ulcers. So I think with that, I think I've become quite comprehensive. I hope I have not left out anything, but these are the tests you have to do annually.
Thank you all. Thank you.
A sincere thank you to all the panel members for the most informative session on can diabetic patients live a carefree life with the help of technology. And also a sincere thank you to Dr. K. Srinivas, who conducted this panel discussion very smoothly. Now I would request our volunteers to come on the stage. And may I request Dr. Srinivas to hand over the mementos as token of appreciation. Firstly to Dr. Vinay Chauhan. Dr. Mala Dharmalingam. Thank you, ma'am. Your information is quite useful. Thank you for that. And next to Professor Radhakant Padhi. And may I request Professor Radhakant Padhi to hand over a memento to Dr. K. Srinivas. Thank you all. Our next event is visiting to exhibition stalls. We would request all of you to join us there.
Yeah, it is not really a break. It is not really a break. We actually purposely closed down the exhibition site because this is the time for another session out there, just the opposite hall. Just there are 6 stalls out there, and I think 5 are already there before starting. Maybe 6th one is also on. Spend some time, 5-10 minutes each. You will actually see a product. You can also go do your foot testing and all that. That is always possible. Busy meter testing is available. All that activity is there for next half an hour.
Welcome back, everybody. ನಮ್ಮ ಹಿರಿಯರು ಹೇಳಿರುವ ಒಂದು ಮಾತಿದೆ, ಒಂದು ಮರದಿಂದ ತೋಪಾಗುವುದಿಲ್ಲ, ಒಂದು ಸಂಸ್ಥೆ ಅಥವಾ ಒಬ್ಬ ವಿಜ್ಞಾನಿಯಿಂದ ಸಮಾಜದ ದೊಡ್ಡ ಸಮಸ್ಯೆಗಳಿಗೆ ಪರಿಹಾರ ಸಿಗುವುದಿಲ್ಲ. ಅನೇಕ ಜ್ಞಾನಿಗಳು, ಅನೇಕ ಕ್ಷೇತ್ರಗಳು ಒಂದೇ ಗುರಿಗಾಗಿ ಕೈ ಜೋಡಿಸಿದಾಗಲೇ ನಿಜವಾದ ಪರಿವರ್ತನೆ ಸಾಧ್ಯ. ಇಂದಿನ ಕಾರ್ಯಕ್ರಮದ ಉದ್ದೇಶವೂ ಅದೇ. Every great journey begins with bringing together great minds, and today's program is a testament to the power of collaboration between science, healthcare, industry, and public service. May I now request our distinguished dignitaries to kindly join us on the dais. May I first invite our chief guest, the Honorable former Chief Minister of Karnataka, Shri B.S. Yediyurappa, to kindly come onto the stage. May I request Shri G. Mariswamy, Honorable President, Bengaluru Urban Jilla Panchayat, representing the Honorable Minister for Health and Family Welfare, to kindly join us on the dais. I also request Professor Radhakant Padhi, Program Coordinator and Professor, Department of Aerospace Engineering, Indian Institute of Science, to kindly grace the stage. ಅಸತೋಮ ಸದ್ಗಮಯ, ತಮಸೋಮ ಜ್ಯೋತಿರ್ಗಮಯ, ಮೃತ್ಯೋಮ ಅಮೃತಂ ಗಮಯ. Lead us from untruth to truth, from darkness to light, and from mortality to immortality. I now request our dignitaries to kindly step forward to light the ceremonial lamp. In Indian tradition, we believe Atiti Devo Bhava. Our guests are akin to the divine. Today we are privileged to be in the presence of leaders who have dedicated their lives to public service, scientific excellence, and societal development. As a small token of our gratitude and respect, may I request our organizing team to felicitate our distinguished guests. ಮೊದಲಿಗೆ ನಮ್ಮ ಮಾಜಿ ಮುಖ್ಯಮಂತ್ರಿಗಳಾದ ಶ್ರೀಯುತ B.S. ಯಡಿಯೂರಪ್ಪನವರಿಗೆ I would request Professor Padhi to come on the stage, please. I also request our Registrar, Professor Nagesh, and Dean Mechanical, Professor Satyam Suhas, to join us on the dais. We also want to appreciate Shri G. Mariswamy, President, Bengaluru Urban Jilla Panchayat. I would now request our dignitaries to take the seat of the dais. We will be starting with the presentation by Professor Radhakant Padhi. Every meaningful initiative begins with a vision. Today's program is the outcome of a vision that engineering and technology can make healthcare more affordable, accessible, and equitable for every citizen. To share that vision and introduce the purpose behind this initiative, it is my privilege to invite Professor Radhakant Paddy, Satish Dhawan Chair Professor in the Department of Aerospace Engineering and an Associate Faculty at the Center for Cyber Physical Systems, whose interdisciplinary work continues to inspire innovation beyond conventional boundaries. Today, through his deep tech startup, he is leading the development of AI-enabled affordable technologies that are transforming diabetes care for millions. Ladies and gentlemen, please join me in welcoming Professor Radhakant Paddy.
All right, good afternoon, everyone. And thanks our chief guest, Honorable former Chief Minister, Dr. Yodurappaji, for coming and having spending some time with us. And thank all of you for coming here and spending some time with us. This is actually not going to be a formal presentation per se. I'll just give you some 15 minutes of your time to kind of give an overview of what's going on actually. It's not really something very detailed or anything like that. Okay, switch off the light now. All right, so this is going on. So this is, if you really talk about diabetes care and diabetes care methods, all of you probably know that it's a very, very big problem. There are a lot of people are getting diabetic. Invariably, everybody will have somebody or other in the family of diabetic, and a lot of us in this community also have diabetic. So in the sense, if you really talk about global and also Indian, it's a very alarming figure. So 10 crore people are actually having diabetes in our country as well. So then there are current methods that really talk about a lot of pharmacological interventions. There are multiple daily insulin, daily changes of exercise plans, all sort of things are there. But then having said that, these are all not very convenient. They are also very difficult because you talk about poor patient adherence, risk of hypo and hypoglycemia, high sugar, low sugar, like that. All these things are not really working that well. It is much better than what it was there before, but certainly not that one. So IISc, if you talk about a little bit of glance of IISc founded more than 100 years back. Now we have grown leaps and bounds. There are so many programs, everything is happening. You name science, you name engineering, we are having it. So everything is there in part of it. Of course, it started with a big vision of, the giant data long back, supported by Mysore King, and now fully supported by India government, also state government. There, everywhere we get support basically. And then if we talk about IISc has gone into 7 different fields and also including medical science. And it is not medical science means only medical science people work, not really. All of us working in metallurgy, mechanical, aerospace, robotics, everybody jumps into that. But somewhere or other we feel that we can contribute, we do want to contribute. And that is how it has gone. So of course there is very impactful contributions from IISc on diabetes care. So I'm just next to 2-3 slides, I'm going to summarize whatever you've seen it 1 hour before. So one at a time. But this is in addition to that, very recently we had some AI Center of Excellence for Healthcare, and that was primarily for translational AI, application-oriented AI for universal healthcare. There are so many things out there, and this is called Tanu. But then essentially it is actually talk about a very important part which talks about diabetes management also. So that is actually what is happening here. But then a little bit glimpse of what Siddharth told just before this session, that a lot of cohort studies are done. Several database is getting generated here. So this database is available publicly. Everybody can do research based on this outcome basically. So that is also as part of our thing. That's predominantly led by Professor Siddharth Zunjunwala and team. And this one you have also seen a talk from Professor Anand Suresh. It's a very impactful work. So essentially diabetes podiatry. Essentially a lot of people get into foot problem, foot ulcer and all that, primarily because there are pressure points actually. The pressure should be distributed throughout the foot. Now the question is how do you do it? So essentially very good compliant mechanism. He's an expert in compliant mechanism. And in fact, more or less we have been classmates in some sense. Basically also together we study something very similar things. So essentially talk about very nice add-on. You don't have to buy a shoe. Just take that add-on patch and put inside your sole, and then shoe becomes suddenly very much pressure distribution point and all that. Those of you who want to have some sort of feeling, there is a stall out here, and you can actually have the feeling of foot taste and all that. So essentially there is a patch sort of thing, this one you buy, and then insert inside your sole and put some sort of a layer, then you are done basically, right? That is what is happening here. So it's a very impactful work again, going to actually public use already basically. Then you talk about another fantastic development. We talk about an anupath, very tiny small glucometer. But it started like a albumin test and all that, but then the glucometer has gone leaps and bounds. You can do several studies, and it's gone to a lot of government level, public health, lot of these private hospitals. In our own Bangalore also, there are so many people have taken into account. So this is no more a lab research anymore. These are all getting to translational research for public benefit, actually. Okay. Then finally comes to our team. Our team also talks about some sort of a AI-based solution that essentially talk about smartphone-based, whether we can do all sort of this service-oriented thing. We also realize that if you talk about insulin pump, then that is one of the things that is very expensive. One insulin pump talks about 3 lakhs. If it is closed loop, 6 lakhs. Many people cannot buy that. So we have a dream of making that 1/3. That means you can talk about an insulin pump that is available at 3 lakhs. Can we generate a similar, or can we design and develop and certify a similar insulin pump, which will be 1/3 of the cost? Similarly, if we talk about closed loop, the closed loop cost will be not only 1/3, the quality will be 3 times more. In other words, we'll tailor it ourselves, our entire algorithm for the Indian population. That's what we are talking about. So a little more into that. So essentially, if you talk about high-tech solutions for diabetic management, you have got smart insulin pens, you have got smart glucometers, then insulin, again this is insulin pen, but this is insulin pump. So pump is much better than pen because it can give very small dose throughout the day, 24/7. So essentially talk about that. So essentially smart pen, glucometer, continuous CGM, then insulin pump. Then can you make it, this sensor and pump talk together and make a closed loop system? That's what. So this is what is actually the very high-tech thing that goes on in the entire thing. It's very difficult problem as well. And you talk about finally, we thought we can contribute in this smart. It's also the smartphone-based app and all that actually. So that is what you are going to, another 3-4 slides probably. So this is what we started in about 10 years back, got some grant about some imprint, MHRD and ICMR together, and that is how our journey started about 10 years back. But then we also continued to phase 2, we supported by various Ministry of Education, some private foundation and also Department of Biotechnology. So our journey has been something like this. We started something like about 2017, based on background research and all that. And then we came up with the closed loop part of it. In fact, during COVID time also we have done these clinical trials in Ramya Medical. And also now these are some of the clinical trial tests. Now we are getting into insulin pump and finally smart care applications as well. So this is what it is. So next few years we are talking about getting into certification studies and then can you actually say, kind of make it available. And biomedical things are time consuming, so you have to be a little more patient for that. So essentially this is the closed loop architecture. So essentially this is what is happening. You take some food, then the blood kind of senses that you have taken some food, sugar is high, then it goes a signal to the brain, and the brain gives a signal to the pancreas, and the pancreas releases insulin. And that is such a fantastic control system. Brain almost knows exactly how much you take. So a little more sweet means little more insulin. Little less sweet means, okay, glucagon starts basically. Suppose you do fasting, then instead of insulin, they actually it gives glucagon. So that's why for long fasting you don't feel hunger. When you do long fasting, you actually don't feel hunger. Primarily because it's not only insulin, it actually gives the opposite hormone. Opposite hormone is glucagon basically. So all these things are nicely happening. Now the question is, okay, if you don't have some partial failure of this mechanism, this is a fantastic control system by the way. So partial failure type 2, complete failure type 1. That means pancreas are simply dead. They are not actually talking about any insulin basically. That is the point where you talk about external insulin. The question is, if it is like that, what do we do? Now in engineering sense, this is what we do. So essentially something like this. Now this is not working, so we talk about exact replacement of that. So instead of a biochemical sensor, we now talk about a electronic sensor, again from biochemical research. Then you talk about instead of a brain, you have a smartphone and there is a pump. The pump gives you exactly small amount of insulin. By the way, just for information, entire amount of insulin that is needed for the 24/7 control is just about half ml. So half ml you have to give on 24 hours the spread. So that tiny amount of insulin you cannot give it by hand. It has to happen by the pump only basically, right? And when you take food it is more, when you don't take food it is less. All these algorithms are there part of the thing basically. So our journey started with about 10 years back. So and again, why it is such a difficult thing to do it? There are reasons for that. The reasons is actually you can only give insulin, you cannot take out insulin from the body. You can have measurements are not there. So essentially sensors are not very good. Only one sensor is there. Then you got a lot of variability. Different patients behave different things. Then you talk about septic criticality test. We cannot give little more insulin. Remember the value is so small that you give little more, it becomes 100% more. That means it will go to hypoglycemia actually. Right? You talk about sugar getting low. Then there are this variability has to be there because 24/7 you have to give that exercise, right? So I cannot get a bigger one, just small one that way. Then exercise, meal, all these things has to be taken into account. So novelty is there. Of course, I'm not going to take you through. So our algorithm has several novelty. partly bought from aerospace engineering. I do work on aerospace engineering. We got contributions in fighter aircrafts, this Chandrayaan mission, all that is there in that is our strength. So we talk about all this predictive algorithm, personalized need, adaptive learning, robust performance, all these things are built into that basically. And then we talk about, well, some 50 plus clinical trials already done, 20 closed loop also done, and now it is partnership with MDRF Chennai, and also MS Ramaya Medical is always a partner, and also a partnership with the GIMS Government Institute of Medical Science in Noida, Delhi. So also our target price ultimately, this particular thing what is available in market right now is about 6 lakhs, and that actually uses something called PID control. There's a very basic control that we teach to undergraduate students, but then it is nothing predictive there, a little bit of intermittent bolus control like that. So this algorithm is much way superior basically. So that is what you are talking about here. Of course, you have got insulin pump development. This is actual pump. You can see all that is going on there, and we are redeveloping it now for certification purpose. The demonstration is already done, mechanism is already done. But now you have to redo, because in certification you cannot use certain program language, you cannot use certain hardware, you cannot use certain things, lot of things are there. So we have to redevelop that, and we are going through that process. Okay. So essentially it is built for very daily use, so very smartphone integration also is possible. You can talk about touch interface, you can talk about compact, you can talk about waterproof, you can talk about many things that are there. So don't think that because price is small, the quality is going to be compromised, not really. Quality will be much better in fact. Okay. Only thing that we can probably compromise is the compactness. Our phone will be slightly bigger, maybe about 30% bigger size and a little bit more weight, that's all actually. Otherwise it is nothing there basically. Okay. And this is a demo of what you can do. You can actually tailor all the dose, you can tailor all sort of things, that is all sort of things are done. Now coming to the last part of it, so we have also talked about a smartphone insulin, smartphone development app especially, which is CGM integrated. That means you put a CGM, a coin sort of sensor here, and then it keeps on giving data every 5 minutes. That every 5 minutes data gives you a lot of information about how it is growing, how it is coming down, which food is actually working for you, which is not working, during sleeping what is happening, are you sleeping or have you gone to coma? All these things are actually possible through this mechanism. Now that you have this sensor, you can actually build a very nice smartphone app which can talk about interactive. It can talk to doctors, it can talk to caregivers, it can talk to this yourself, and cloud integrated by the way. So the integration happens through Amazon Web Service Cloud. So all the data that is getting generated by your sensor, even though your son is not living with you, living with US, you can still see it in real time. And if it is night here, it will be day there. So of course, if you are not waking up, then the sun will wake you up. Will call you something like that. So that kind of things are also there. So you got features. Of course, it is more accurate. It's got smart alerts. Smart alerts means when it's going up, going down, you should get alert system everywhere. Then talk about medicine. There are so many other things that you can see. Medicine delivery, meal and activity tracking, video consultation with doctors, home lab test. Lab test, you don't have to go anywhere. Lab test fellow will come to your home to take the test. So you're sitting in home, you'll get a fantastic diabetes care with the help of this technology basically that you're talking about. So all these things are possible. In fact, we had a lot of problems in getting it uploaded to Google and Apple. They also scrutinize you very well, whether you have done it properly, not properly, whether interfering with other app. All sort of things are done, and then eventually they have taken in basically. So there are a lot of features. In fact, this is one thing that I keep on telling everywhere, that even if you buy expensive sensor, the sensor company cannot really customize to you because they don't know you. So they'll customize to many people together, but then individually it may not work well. So if you do a little bit of calibration, when you buy a sensor, 4 or 5 BJ meter testing, finger testing you do, and then you enter the time and data, and then you will compensate for errors. From there onwards, it will become very customized. You can see that this is the raw data that the sensor gives you, and this is the calibrated data after you do that, our algorithm. It actually matches very well with the IV data. Whatever they talk about IV data, you take from here, and that will match with that data basically. So that is just 4 or 5 times you have to do, that's all actually. So there are all these things, these errors will be compensated. Now it will be very customized sensor, very accurate sensor. So whatever prediction you will do, hyper and all that will be very accurately predicted. That's the thing, that's one of the USP. Then there are several things you can do through this app. Those of you can download this app, its QR code is here, and then play around it. You don't have to subscribe, just play around with all that. You have got a lot of things that is coming up here, a lot of service oriented things. Let me not explain one by one. So you have got video consultation, you have got meal, medicine, insulin logging, you can talk about ordering medicine, you can talk about fitness integration, all sort of things are actually done. And thanks to our techie people led by Divya herself. Divya is with me for about 6 years now. So led by her, we have actually done many things together. And then, of course, you talk about multiple roles out here. So one person can actually, not only are a patient, you can also be a caregiver. Not only are a patient and caregiver, you can also be a doctor. So all this permutation combination has been accounted for. So you can also talk about not only my son is watching, I want to give my right to my son, 2 sons, 1 daughter. Can I do it? Yes, you can do it. Up to 3 people can do it. Similarly, one person, let's say we want to become caregiver, you want to see 3 different patients. Can you do it? Yes, we can do it. So all these permutation combination, multiple doctor, multiple caregiver, multiple patient, everything is done actually. Then comes out the difficulties that you can talk about, lot of analysis. After you generate the data, whether it's working or not working, what is happening. Then you got a chatbot, chat GPT integrated, all that can be possible. And now we compare, we thought we got integrated, kind of interested, that what all are available in the market and what all features we need. So we can actually put a table out there, and of course only this thing is about half done, about 70% done. Rest of the things are actually done here. So again we are talking, just because you are getting it cheap or getting it free, I will talk about very cheap, very compared to every other thing. Whatever you get here, our thing is cheaper than that. Just because it is cheaper than that, you don't have to compromise on anything. Basically, you will get much better than that in fact. So these are just 2 systems. Give me 1 minute. I will not explain anything. We talk about a very well thought out architecture. We talk about Flutter, Express Node, all sort of things there. That is very technical. I am not going to get into that. We talk about AWS integrator, which is Amazon Web Service, operating in Hyderabad somewhere. All the data goes there and then gets everywhere there. And then you talk about how do you do that. So there is something like a very good software architecture through this API integration. There is something on back end, something on front end, all that. I am not getting into too much on that. So then everything will be operating on database finally. So, and then the point of why I'm talking about then is lot of thought process very systematically has gone through. Even though I'm not a software expert. I'm actually expert in control system, I'm expert in aerospace, I'm expert in other things. But thanks to our team again, they have actually digged out everything, and it is ably led by one more very intelligent, very capable person. We call him as technology director. So with that, both of them have done so much of work in the back end. I'm not going to scare you. I'm just telling a message that a lot of thought process has actually gone through to do something called microservice architecture. Then each and everything will be operating almost independently. That means even if you don't have a sensor, the rest of the things will work. Even if doctor appointment feature is not working, other features will work. So all these things. So essentially you can, while you plug the issue, the other features will keep on working. Now comes the data integration. So much of thought process you have to do, which will go where, what will happen, if some wrong interpretation, what will happen, how do you cure it, all this I'm not going to explain, but it is done basically. Then comes the security features. When you do the data integration, data upload, download, all that you do, there are security issues. So you have to talk about data security here, and everything is something called DPDP guidelines. So that digital data protection guidelines basically. So that is from Government of India, and we have actually followed that architecture as well basically. So nothing to worry. So there are benefits to patient, there are several benefits to happens to the patient. Patient will come under a very big care umbrella, and that umbrella will give you certain lot of features there. You will get into very good glucose tracking, improved HbA1c, dietary tracking, all sorts of things happen. Now doctors. Doctors will also, I'm not telling that because of this doctors will go jobless, not really. One doctor can treat many patients at the same time. So essentially they will get a summary of all the people, and then they can play around with all these things, and then with their time efficient management can happen. So a very good expert doctor can treat many people actually. So that way basically, right? So then you can talk about several things all out there basically. So all of course, you have got access through multiple devices. You can access both through laptop as well as through tablet. You can do computer, phone, all that thing. Now, you don't have to only phone or only tablet or only laptop, not really. Your login ID will operate everywhere actually. So that is also there. And of course, you talk about several things will happen for doctors as well. They can treat many patients. And see, for the doctor, I see money is not that important. The doctors, what they see really is the patient smiling. 100 people smiling because of me, that is the satisfaction that no money can buy. I mean, that is, I think I seriously believe about that. Probably Dr. Sekonda can talk about more when he gets a chance there. And then talk about, we had a beta release, we had some release before 6 months back. What all improvements you have done? There are several improvements you can talk about. Now it is a very big task to get there because people's confidence comes there. If you download from the right platform, then you can do a lot of confidence. That goes through a lot of scrutiny. Then you talk about, smoother, lot of this UI, UK talk, user interface, user experience, that has improved, stability issues enhanced, the stability issues addressed, enhanced graphics. Also talk about, this medication reminder, decision of when to take what. Then AI assistance also is there that way. And of course, a lot of user trials have been done, continuous feedback, we have improved all that. In fact, we invite all of you to kind of help us spreading the message. It is not really about money. We don't want to make profit. They just want to have break even so that company can sustain, and also it will go to many people's benefit. Our country really needs high tech with low price, and that is what the bottom line. And with that, probably I will thank our team, and the team is very good. We have actually been led by Dr. Abhishek. He's a PhD student with me, but after that he continued to stay. All these people are there in front of you who have actually helped us quite a lot. In fact, our clinical partners are doctors, very, very famous doctor. Dr. Mala was also there in the pictures. He was giving a talk today morning. But because he moved away from Ramaya. So right now she is not a partner, but she is also a partner. But you can see a lot of good things here, and advisors are also there, and that's all about from my side. Thank you very much.
My sincere thank you to Professor Paddy. A lot of good work has been happening with your team. We wish you good luck and a lot of success. The talk was on automated insulin delivery system, wonderfully presented. Thank you. We move on. Swami Vivekananda once said, "They alone live who live for others." Few leaders have embodied this spirit of public service as consistently as our chief guest today. It is a matter of great honor for all of us to welcome the former Chief Minister of Karnataka, Shri B.S. Yediyurappa, whose leadership has always emphasized development, education, healthcare, and the welfare of the people of Karnataka. Sir, your presence today inspires all of us and reinforces the importance of science and technology in serving society. Ladies and gentlemen, with great respect, I invite Shri B.S. Yediyurappa to kindly address the gathering.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Distinguished guests, member of the scientific and medical community, ladies and gentlemen, I am delighted to be at the Indian Institute of Science, an institution that has brought great pride to Karnataka and to our nation. IISc has shown how knowledge and innovation can improve the lives of ordinary people. That is the true purpose of science. Today, we are taking another step towards making quality healthcare more affordable, accessible, and available to every citizen. Diabetes has become one of the biggest public health challenges of our time. It affects families in our villages and much as in our cities. I congratulate IISc and Vishvasys Technologies for transferring research into solution that can benefit millions. ನಮ್ಮ ವೈದ್ಯಕೀಯ ವಿಜ್ಞಾನಗಳ ಸಂಶೋಧನೆಗಳು ಕೇವಲ ಪ್ರಯೋಗಗಳಿಗೆ ಸೀಮಿತವಾಗದೆ ಹಳ್ಳಿಗಳ ಕೊನೆಯ ಪ್ರಜೆಯನ್ನು ತಲುಪಬೇಕು. ಬಡಜನರು, ನಮ್ಮ ಅನ್ನದಾತರು, ಕಾರ್ಮಿಕರು ಮಧುಮೇಹದಂಥ ಕಾಯಿಲೆಗೆ ತುತ್ತಾದಾಗ ಅವರ ಇಡೀ ಕುಟುಂಬ ಆರ್ಥಿಕವಾಗಿ ಕುಸಿಯುತ್ತೆ. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ನಮ್ಮ ಪ್ರೊಫೆಸರ್ ರಾಧಾಕಾಂತ್ ಪತಿ ಮತ್ತು ತಂಡದ ಆರ್ಟಿಫಿಷಿಯಲ್ ಪ್ಯಾನ್ಸರ್ಸ್ ಕುರಿತು ಸಂಶೋಧನೆ ಜನರ ನೋವಿಗೆ ಸ್ಪಂದಿಸಲು ನಡೆಸಿದ ಒಂದು ದಶಕದ ಸುದೀರ್ಘ ತಪಸ್ಸು. ತಂತ್ರಜ್ಞಾನ ನಮ್ಮ ಗ್ರಾಮೀಣ ಭಾಗದ ಜನರಿಗೆ ಆಶಾಕಿರಣವಾಗಲಿದೆ. ಮಧುಮೇಹದಿಂದ ಪಾದದ ಸಮಸ್ಯೆ ಎದುರಿಸುವವರಿಗೆ ವಿಶೇಷ ಪಾದರಕ್ಷೆಗಳು ಮತ್ತು ಇಂಟರ್ನೆಟ್ ಆಧಾರಿತ ಇನ್ಸುಲಿನ್ ಪಂಪ್ಗಳು ಕೇವಲ ಉತ್ತಮ ಆವಿಷ್ಕಾರಗಳು ಮಾತ್ರವಲ್ಲ, ಅವು ಲಕ್ಷಾಂತರ ಜನರ ಸ್ವಾಭಿಮಾನದ ಬದುಕಿಗೆ ನೀಡುವ ಕೊಡುಗೆಯಾಗಿದೆ. ನಾನು ರಾಜ್ಯದ ಮುಖ್ಯಮಂತ್ರಿ ಆಗಿದ್ದಾಗ, ಅದರಲ್ಲೂ ಸಾಂಕ್ರಾಮಿಕದ ಸಂದರ್ಭದಲ್ಲಿ ಆರೋಗ್ಯ ಮತ್ತು ಗ್ರಾಮೀಣ ಅಭಿವೃದ್ಧಿಗೆ ಹೆಚ್ಚಿನ ಆದ್ಯತೆ ನೀಡಿದ್ದೆ. ಇಂತಹ ಕೈಗೆಟುಕುವ ತಂತ್ರಜ್ಞಾನಗಳನ್ನು ಸರ್ಕಾರಿ ಆಸ್ಪತ್ರೆಗಳು ಮತ್ತು ಪ್ರಾಥಮಿಕ ಆರೋಗ್ಯ ಕೇಂದ್ರಗಳ ಮೂಲಕ ಜನರಿಗೆ ತಲುಪಿಸಲು ಶಾಸಕರಿಗೆ ಮತ್ತು ವೈದ್ಯಕೀಯ ವಿಜ್ಞಾನಿಗಳು ಒಟ್ಟಾಗಿ ಕೆಲಸ ಮಾಡಬೇಕು. ನಮ್ಮ ವಿಜ್ಞಾನಿಗಳ ಬುದ್ಧಿಶಕ್ತಿ ಜಾಗತಿಕ ಮಟ್ಟದ್ದು. ನಿಮ್ಮ ಹೃದಯ ಭಾರತದ ಬಡವರ ಪರವಾಗಿರಲಿ. ನೀವು ಸಂಶೋಧಿಸುವ ಪ್ರತಿ ಸಾಧನವು ಒಬ್ಬ ಸಾಮಾನ್ಯ ಮನುಷ್ಯನ ಕಣ್ಣೀರನ್ನು ಒರೆಸುವಂತಾಗಲಿ. ಭಾರತವನ್ನು ಆರೋಗ್ಯವಂತ ರಾಷ್ಟ್ರವನ್ನಾಗಿ ಮಾಡಲು ನಿಮ್ಮ ಕೊಡುಗೆ ನಿಜಕ್ಕೂ ದೊಡ್ಡದು. ಮಾನವೀಯತೆಗೆ ಸೇವೆ ಸಲ್ಲಿಸುವುದೇ ವಿಜ್ಞಾನದ ನಿಜವಾದ ಯಶಸ್ಸು. ಪ್ರತಿಯೊಬ್ಬ ನಾಗರಿಕನ ಕೈಗೆಟುಕುವ ಗುಣಮಟ್ಟದ ಆರೋಗ್ಯ ರಕ್ಷಣೆ ನಿಟ್ಟಿನಲ್ಲಿ ನಾವು ಕೆಲಸ ಮಾಡೋಣ. ಮತ್ತೊಮ್ಮೆ IISc ಮತ್ತು ಈ ಗಮನಾರ್ಹ ಸಾಧನೆಗಳಲ್ಲಿ ಭಾಗಿಯಾಗಿರುವ ಪ್ರತಿಯೊಬ್ಬರನ್ನು ಅಭಿನಂದಿಸುತ್ತೇನೆ. ನಿಮ್ಮ ನಿರಂತರ ಯಶಸ್ಸಿಗೆ ನನ್ನ ಶುಭ ಹಾರೈಕೆಗಳು. ಕೊನೆಯದಾಗಿ ಹೇಳಬೇಕೆಂದರೆ, ಬಲಿಷ್ಠ ವಿಕಸಿತ ಭಾರತದ ನಿರ್ಮಾಣದ ನಿಟ್ಟಿನಲ್ಲಿ ನಮ್ಮ ಜನತೆ ಆರೋಗ್ಯವಂತರಾಗಿರುವುದು ಬಹಳ ಮುಖ್ಯ. ಇಂಥ ಆವಿಷ್ಕಾರಗಳ ಮೂಲಕ ಮಧುಮೇಹ ಮುಕ್ತ ಕರ್ನಾಟಕ ಕಟ್ಟುವುದು ನಮ್ಮ ಸಂಕಲ್ಪವಾಗಲಿ. ಎಲ್ರಿಗೂ ಧನ್ಯವಾದಗಳು. ನಮಸ್ಕಾರ.
Research becomes meaningful when it leaves the laboratory and transforms life. Today's program culminates with exactly such a moment. SugarSight represents the coming together of engineering, medicine, artificial intelligence, and digital innovation to empower people living with diabetes through affordable and accessible healthcare technology. The launch of this application symbolizes our commitment to translating research into real-world impact. It is now my privilege to request our chief guest, Shri B.S. Yadurappa, to formally dedicate the SugarSight app to the people through the Jana Samarpana. May I request all dignitaries to kindly join him on the stage for this special moment. I would also request Mrs. Asima Paddi, who is the Director, Vishvasys Technology, to join us.
Let him sit there. All right, just 1 minute more, just 1 minute. We are almost at the end. So after the chief guest takes his seat, just 1 minute more. We should all profoundly thank our chief guest today for coming up, coming here and spending half an hour at least, and motivating us with his wisdom. And thank you, sir, again for opening this and then dedicating it. We'll just give 1 minute for a little bit of demo, just 2 more slides, 1 minute. Just take your seat, just 1 minute, that's all. So we are ready to kind of just show you how easy it is to get yourself on. So you have to just download the app and go through some name, mobile phone, email and all that. That process is already done. And then there is a sensor. That sensor will already ready. Sensor will be put she is ready. My wife Asima is ready there. So she will just take a sensor and then we'll just tell you how easy it is actually. So after you do that, download and registration process, you just have to scan the sensor once. So Divya is ready. Divya will put the sensor, and then the app is ready. App you have to. She is ready with the app, and then you just it will on. That's all actually. Okay, just give the demo. Just to go to the center. Go to the center. So this is the process that you talk about. So take out. Have you taken out the sensor already, right? That should have shown that. No. So this will be typical. Okay. When you open it from the pocket, this will be typically like this. So you open it, and then you just have to. There is another thing. This one will be separate. You just press it. Then the sensor kind of comes here, and then all that you need to do. This one. When you talk about, there will be another one. And then that box is not there probably here, right? The other one. This line. There is a line out here, and the box will have another line. That line has to be aligned. Then you just press it, that's all. Then you take it out. And then you just take it there and just press it tightly, that's all actually. That's it, done. And then you have to scan it. Just scan it. So first time it has to be scanned through NFC, so your phone should have NFC, that's all. And whenever you don't have this Bluetooth range or something, the NFC scanning will be done actually, basically, that's it. Then the sensor will be operational 1 hour later, and everything is automatic, your Bluetooth and everything, you don't have to do anything. Only thing, when you go out of the Bluetooth range, then come back and scan it one more time. So data will come, every 15 minutes data stored, that will come back. And in fact, even if you forget today, something happens, the cloud data will download, and you see everything, all your history basically. So all that more, I again request all of you to download it, app is there, scan is there, anyway, just play around it, you will get much more comfortable. Thank you very much.
As we dedicate SugarSight to society today, let us remember that the true measure of innovation is not the sophistication of technology, but the number of lives it touches. May this initiative become a beacon of hope for millions living with diabetes. Thank you. Our next program is Fireside Chat.
We now move into an engaging highlight of today's program, the Fire Chat. For this dynamic conversation, it is my privilege to invite Archana ma'am and Professor Radhakant Padi to the stage. Please join me in welcoming them with a warm round of applause.
So good evening, everyone. India is home to over 100 million people living with diabetes. That is 1 in every 7 adults. Every single day, millions of families measure sugar levels, count insulin doses, and worry about costs. Yet, timely monitoring and affordable care remain out of reach for many. What makes today special is that the solutions you will hear about were not imported, they were built here at IISc. My guest tonight is someone the world knows for guiding rockets and autonomous system, but who chose to point that same precision at a very human problem. He is the founder of Vishvasys Technologies, and today he relaunches the SugarSight platform. Please welcome Professor Radhakant Padi. Professor,
Thank you.
Wonderful to have you here. My first question to you. The world knows you for aerospace, control systems, and autonomous technologies. What made a rocket scientist turn to blood sugar?
Well, this is a common question that I always get wherever I go, because essentially I also have a presentation ready for this called AP inspired AP, called artificial, what is that? AP inspired AP. So artificial pancreas inspired from rocket science, actually. That's what it means. Autopilot. AP stands for autopilot in aerospace. Autopilot inspired artificial pancreas. So essentially, they are not too much or difficult. In fact, one of the sad thing or whatever right good thing or sad thing what you can say, it's actually control system people always solve others' problem. Control system is not a discipline by itself. Control system actually solves other disciplines problem. So one time you become aerospace discipline, one time become mechatronics discipline. We can also talk a lot of robotic problems. We can also talk autonomous driving cars. We can also talk. We are always hunting out for problems that we can apply our knowledge to. Control system by itself is not an application, but no application is complete without control system. In fact, every sensor, when you talk about sensor package, there is also a control system. So that is something, sometime back I was also hunting out for many things. In fact, during my PhD itself, I was a little bit inclined for biomedical application, even though I never got a chance to study biology. But all my 11th, 12th also, I have not taken biology, but that doesn't matter. So what happens is, when engineering people look at biology from a different point of view, they will like to do quantization for everything. So engineering is all about systematic study. We talk about not only seeing what is going on, but we like to do prediction as well. So that means the model-driven sort of thing. So in that curiosity, I was doing my PhD. I got into something called parturient pyrosis of cows. I don't know how many people know that. We published some papers and got some IEEE Best Paper Award, this, that. That inspired me a little more. Then a variety of problems started solving. In fact, get into cancer treatment. So cancer is this multimodal therapy sort of thing, right? You talk about this immunotherapy, radiotherapy, the chemotherapy, all that. So one of our studies shows that you can do multimodal therapy. In fact, a lot of times what they do is they especially go for cancer is If it's a solid tumor, they get a surgery, then they follow chemotherapy, then they follow immunotherapy, it's a sequence of things basically. But what we really talk about, there are certain cancer you cannot do surgery, blood cancer for example, because there is no surgery. Directly start with this chemotherapy. So when you do chemotherapy, a lot of side cells also get damaged, right? Essentially, not only the bad ones go, good ones also go. So then immunotherapy kind of activates the immune system. So essentially, what we found out in a good way, that you can start all these things together. You don't have to wait chemo to be over, then you start immuno basically. So that was our study basically, whether that is right or wrong. We never did any clinical trial. Then I was looking for something else where the control system will operate 24/7. And then diabetes is a fantastic problem, especially those type 1 diabetic, where you talk about automated insulin delivery. And I didn't even know that it was called artificial pancreas. It is simply called blood glucose control. That's all it is. We started with doing that and little fun exercise, and then one thing led to other. Then some postdocs joined. Then we actually, that same is actually faculty in IIT Madras now. So we did something there, and then one thing led to other. Then I got little more interest, little more success. Then at a point came when we actually talked serious research. Then that is the point we got some funding very good way. In fact, couple of my initial grants were rejected because you are talking aerospace and biomedical, you are just not competent. So in fact, our IISc internal system rejected once for me. That's, I don't know how many people are aware of it. Then Indo-US Forum rejected one time. Then finally came this opportunity of imprint thing. That completely changed the ball game. So then we got very well funded, and then we got associated with clinical people. MS Ramaya, whatever, Dr. Mala was there at that point in time. And then from there onwards, a completely different ball game. We also got supported by Dr. Ananda Basu, we should not forget him, that they have done quite a bit of research in their Mayo Clinic and Virginia Tech, now they're in Alabama, in US. And he actually came here, gave a talk, we established quite a good relationship. And all our clinical studies are based on their failures or success. In other words, whatever they have done it, they have actually guided not to do that same thing. So we will kind of prevent ourselves before you go to the whole basically, right, that way. So their contribution is immense also. So we got an ecosystem built around that. Then again, there was a time when many people actually did not want to do our diabetes research. And thanks again, that is exactly God is good, God is great. So Abhishek joined at that point in time. After 1 year, Divya joined, then a completely different ballgame after that. That's how it is.
The journey is so nice to hear. One led to the other, and today we are here launching a product. So the same mathematician that keeps an aircraft stable can also keep a diabetic patient stable. So let's talk about that patient, right? You have interacted with hundreds of patients. Beyond the numbers, what are the biggest day-to-day struggles an Indian diabetic patient faces?
Okay, so before you answer that question, just because you excited that, let me complete the story. When you talk about control system can solve others' problem, you don't really simply go there with like a gunda sort of that. So we are not fighting for anybody. We are actually kind of struggling with them, basically, right? So we actually understand their problem first. When that is, I keep on telling that you can migrate from discipline to discipline, but take your time to study the discipline to best extent possible. Otherwise, understand before you control. So that is what it is. So when you go into biomedical side, the same theory, actually theory part is same, but the concerns are very different, capabilities are different. So in aerospace we talk about millisecond level control, otherwise you are not interested, because before you realize the missile problem is over. So your control system update happens in few milliseconds. A millisecond means what? Before 1 second you count 1,000 times, no? That is 1 millisecond. So we talk about 20 millisecond update, that's what we need, 10 millisecond update. But these things are actually not required in biomedical, because it's very minutes of data. So there are certain things there. And then also talk about what are the difficulties here, because in man-made system, be it robotics, be it aircraft, be it missile, be it Chandrayaan also, once we build the system, more or less everything we know. We know how much is the mass, how much is the moment of inertia, how much, where is the CG, how much mass will be going, how much thrust it will generate, which direction it will go, also how much is the gravity of the moon, all that you take into account and build an autonomous system here, right? But here is a system in biomedical system, you are not in control of it. God is given you a system, right? So essentially, even if I know it's a human body, now your metabolism is very different from my metabolism. So that means that variability is very, very large. And that is a good thing that God has given, by the way, because if variability is small, all of us would not be sitting here. COVID time would all been portrayed only here. So that way, basically. So the variability is good for survival. But then it is good for, very difficult for control system person to operate, because now we talk about large uncertainty. Then also, all these man-made systems, you get sensors very fast. If you take control action in 10 milliseconds, sensor data is available 5 milliseconds. Very, very quick. And then you talk about our aircrafts when you go there, right? It is very, very well instrumented. And each of the sensor will talk about triple redundancy we call. So three sensors are there for every parameter, for reliability point of view. Here, none of that is possible. So we talk about no reliability. I mean, suppose our diabetic metabolism, we talk about something called minimal model. Minimal model has 8 different hormones working together. The sensor that is picking up is not even that actually. It picks up the 9th one. So that, but there is a correlation between that from which you recover. That means the signature that you get in the sensor for your metabolism is very, very weak. So all that thing that is, there are certain good things, there are certain bad things. So you have to study that system first, then apply your knowledge and carry forward. So that is the similarity, non-similarity, whatever. Now coming to your question finally, so I talk about the difficulties. Well, every patient will be fed up. I mean, that's the whole life. It's not that, one thing about diabetic, Dr. Sikanda will agree probably, diabetes, people do not know that they are having diabetes. Because they don't get the symptom unless it is, when you get something that is bad already, whether you got a stroke, you got some foot ulcer, you got something, that is too late already. So because the process of development is very, very slow, and during that process, people think that I am a hero. Nothing has happened actually. Right? Because you don't feel it. I mean, genuinely you don't feel it. Maybe a little bit tired, little bit something you'll feel it, but otherwise, yeah, fine, what is happening actually? I can take a sweet, one bite can I have it? One sweet can I have it? Okay, that becomes habit actually, right? That kind of thing. So this compliance, the patient compliance is actually a very big problem because there is no pain in the body. There is nothing happening in the body. Right? So all that is, pick a finger will tell you blood glucose is high. Or, right, that is what it is. Unless you go to hypo side of the story. Hypo side is normally doesn't happen unless you are already diabetic, it doesn't come. So the people who are pre-diabetic, getting to diabetic, things like that, they don't even realize, in my experience, that there is diabetic. So people say nothing will happen to me. Whatever jo hoga dekha jayega. What will happen, I'll see later. So this kind of attitude is very normal. It is very, very human. Because what will happen 10 years later? Why should I worry about it now? So patient compliance is a major issue. Second issue is availability of resources in a cheaper way. I mean, we are having a session after this. People know that there are solutions, but I cannot afford it. So whatever affordability, I can just go with that. Everybody given a choice, everybody would like to operate an insulin pump, but insulin pump is very expensive. Type 1 I'm talking about. But then it is very expensive. A pen is fine. Okay, I'll just talk about a pen. So there is affordability factor, there is availability factor. There are also, for example, another thing is the dual hormone pumps. I don't know how many people know about it. So every insulin pump comes with a glucagon component also. That is already started happening in US. But then the glucagon is not needed. First of all, it's needed only in emergency. Not every time you need it. And then glucagon is not stable. So that means if you cannot talk about room temperature basically, so that little insulin pump you cannot be refrigerating there. So every time you have to replace that. There are a lot of other issues basically that way. So there are a lot of different things that happens there. That is why diabetes is very difficult. Next problem requires continuous monitoring, requires not only you but some caregiver support. And then doctors, if they want to treat them any patient well, they have to spend time to understand all that. The time means there are so many patients there. How much time they can give, that is also a problem, practical problem. So there are many issues because of which it's a difficult problem.
Thank you, Professor. Since you already started talking about the SugarSight product, can you explain how does your IoT-based diabetes ecosystem work?
I've given a small presentation already, so people probably know about it. So it was actually, when we started doing this, honestly speaking, when I started about 2010, I didn't even know that it's called artificial pancreas. I was just hunting out for my associate professor to full professor promotion. So two more publications. I am good, right? Because then people will count publications like this. It doesn't matter where you publish. IISc is fantastic. You can do whatever problem you want. They will just talk about whichever discipline doesn't matter. And so many number of publications with journal lectures. So in that context we started. But then having said that, when it started taking serious turn and all that, thanks to IISc again, it completely revived the field. And then we become very serious. IISc, by the way, also comes from aerospace. I don't know how many people know Dr. Abhishek Chandrasekhar is there in the stall and all that you can see. He also comes from aerospace. So we actually gel very well. That's he's there, last person there. So that he comes from drone, by the way. So essentially our frequency matches very well that way. But the question is not that. Question not that is sufficient. We now talk about doing deeper and deeper things. So one thing, not about just the morning cycle. Once you started morning cycle, there was a lot of failures. Sometimes sensor will fail, sometimes something happens, sometimes the sensor quality not good, sometimes you put the phone directly there and then the phone hits up, then the sensor hits up, sensor fails. Many things that happen and it can lead it to a frustration loop, by the way. So that is also there, we overcome that somehow. And then we talk about, well, this is too many things to do. That means first of all we started with only this glucose water, morning glucose water, 80 grams of glucose water something. After we tried several things, just before the project ends in March 2022 we got some two success basically. The project was extended 3 years to 5 years because of COVID. Again, thanks to COVID or not, I don't know. But because of COVID, it got extended. We got the fantastic result in the last month of our 5-year project. And that motivated obviously a little more actually. Then we talk about now glucose water is not sufficient. Nobody drinks the glucose water. So can you give something more? They talk about, yeah, we talk to Dr. Mala and yeah, we'll talk about something called Ensure Plus. It's a diabetes food actually. So Ensure Plus is also glucose, but it also comes with a little bit of protein, fat and all that. So we migrated to that. That works. Then you talk, no, nobody talks Ensure Plus. Can you really give idli vada? Okay, right. So that is actual breakfast. That also happened. Then in the current phase, we have gone to Chennai basically. So there we are talking about actual South Indian food. Because they have got a calibration loop and all. So one thing leads to other. Then we talk about, well, everything is done, then what about exercise? Somebody pointed out. So exercise also we talk about something theory. Unfortunately, these are very expensive. By the way, see, one of our closed loop trial talks about a week, and one trial, whether it is success or failure, we end up spending about 1 lakh rupees. And that one trial, basically. So that is almost 80,000-90,000 it comes actually. So because of, patient has to come twice, they have to go hospitalization, you have to pay for their bills, you have to pay some, all insulin, all expenses, or sometimes sensor will be 3-4. So all that expenses taken together, it's a very time consuming exercise. Again, thanks to MDRF, again, they are there also. I didn't know that. They're actually, all right. So we'll get there. All right, so it's essentially you get a very complicated loop. So it's not that easy. So that is why this particular research in the clinical trial setting is very rare in the world. And in fact, we are the only one in the country probably because we have been somehow unfortunate successful to do this. Because otherwise, this is just too much of a thing to ask for. Because clinical trials also, do a little bit quicker test, multiple tests is possible. If you just talk about a sensor test, that multiple thing give a lot of sensors, people generate the data, give you the data. That's the easier part. Then there comes the closed loop part. Closed loop part, again I'm talking about variability, right? I mean, 2 days back, we take the blood sample, get everything, control system fit, all these things customized. 2 days later you go, patient variability is there. Now that control system, what you actually designed for, doesn't work after 48 hours. So that way, then you talk about why it doesn't work. Then you talk about chasing it down. So can you really chase it down? That means there is some sort of AI loop which will keep on tuning to your body dynamics. Now whatever you tune for day 0, it will keep on learning from whatever model is predicting, whatever sensor is giving. So between that error, it will keep on learning your model, model parameters, so it will get customized to that. That is also not sufficient. And then you talk about that is not everything. So there are other parameter variability, right? How do you do about that? So they talk about something called uncentered, there is something in our theory, something called Kalman filter. There is Kalman filter, extended Kalman filter, uncentered Kalman filter, all that is there. So there is no probably that way. So the uncentered Kalman filter where something like a Gaussian distribution you talk about. So parameters that are not accurate, but mean value is available. Some value I got it, but it can be anywhere between that. That range is there. So you talk about each of the parameter you got minimum value, maximum value. I got a number, but it can be anywhere between that. That is all our biomedical papers are also like that, right? Plots are there, dots are there, that some bar will be there. That means I don't rely on my value, bar can be anywhere like that, right? So that means all these parameters that I am talking about will have this plus minus value. Then we figured it out, there are four parameters like that other than this dynamics, whatever rate of change of glucose. Then we talk about, okay, 4 in minimum, maximum and center point. If we talk about, there are 9 parameters like that. So for our control algorithm treats the patient like a 9 patient basically. And then you talk about Gaussian system theory, Gaussian variability and all that, when you talk about that way. Actually these 9 support parameters, what you call, so they called, support points and all that, we call that way. So from that, they represent the infinite points. Essentially, they are class leader sort of things. So if you take these 9 points where there is something called sigma points. They are not minimum maximum value. Something called sigma points. These sigma points, there can be definite calculations. When you take these points and treat them as another patient, they essentially are catering for infinite patients in that. So that way, the entire box, that uncertainty box, you are kind of covering. Now we are computed 9 parameter. Which one correct for you? So that out of this 9, we are selecting something called least risk variable. Whichever risk is minimum, we take that. So there are a host of algorithmic development goes in that to make all the things acting together basically. So that's why I told it PID based control, somebody talks about 101 control, things like that. Basically very basic control. Probably it is not that intelligent actually in that.
On the same note, Professor, today we have relaunched SugarSight, but in the market, there are so many different diabetic apps out there. How is SugarSight different from these apps?
Okay, how many of you remember the slide? I put a slide, no? Big slide, some class mark, truck mark, all that is there. So we have actually compared with about 9-10 different availability. There are something called SugarFit, There is something called beta, which help me, what are they? There beta, tomato, all that is there. There are many things are there actually. Okay? So there are something inside India, something outside India. There is a very good platform called Bito. There is also called SugarSight, by the way. I'm no disregard to anybody. They are also done fantastic work, but there are tons of very well funded, by the way. They can do a lot of marketing funding and all sort of things that way. But having said that, if you remember that chart that I put it, there are so many different things that users will like to have it. So those things are probably not there in other apps, and number one. Number two is our system, I've given you 2-3 slides. I don't know about the internal things what they are doing. Nobody will talk about that openly. So we don't know how much is the data security, where your data is going, that is whether they are complying or that. But they may be complying, I'm not denying that. But then whether they are complying or not, we don't know. But for our sake, we can certainly tell that your data is secured and compliant, DPDP compliant. That because anything that is unethical, we simply a no for us actually. Yes, because you are not here to do any kind of billion, that is not there in our thing. The question is, we got a problem that we think that okay, before retirement we can make use of somebody's life or something. That is the motivation here. So essentially, we have a lot of things that you saw that comparison. So those of you are interested, by the way, the comparison chart slide is available in the stall also, right? So we can go back again there. You can, if you have forgotten, there is a slide running there also in our stall. There is a printout also there, which talks about what are the benefits, what you talk about. But again, I emphasize that just because the right-hand side column is all tick, doesn't mean our price is high. Our price is lower than everybody else. I can guarantee that. And if in fact, like there are some offers there, no? If you find out something cheaper than that, then we guarantee you, I declare it without talking to them, that the differential price will be returned to you. I mean, this is a promise actually. So this is not that way. So it is very good platform and be reliable. And in fact, we need your help to spread the message, because the power of social media, WhatsApp forward is second to none. So you can actually take the help of that. In fact, those are attending online also, I request them. The power of words is nothing, I mean, you cannot imagine how powerful they are actually. So but before you do that, I encourage all of you to use one time at least, help us doing that. One time sensor you put, even though you are a healthy person. Doesn't matter. You see the data, no? And you double check yourself and be assured that you are a healthy person. You are, right? That will tell you. So it is worth of 5,000 rupees. I mean, some 4,000 something you are selling, 4,500 sensor something you are selling actually. Right? So put a sensor 4,500 and take the app free. App is one month free anyway for everybody. So you don't have to pay anything. Now, once you are confident or once you are comfortable that you see the value, then only talk about subscribing us. Okay. So that is the guarantee. In fact, all others give 1 week free, 2 weeks free. So nothing like that. We will give 1 month free. Okay. So that then you use 2 sensors if necessary. Get fully compliant. If you find some error or something that you want to improve, tell us. We will do it for you. In fact, all these things that has happened for last 6 months, no, last year, November 23rd, when you had the pre-launch and whatever it is, from there so many improvements happened because of the feedback. Our team is always ready. We will keep on doing whatever you tell. None of the comment will be dishonored. You don't ignore anything, by the way. So we talk about it. Keep on improving. It's a continuous process. So summarizing, it is a very good app. It's not about app, by the way. It is actually something called app bundle. In fact, you buy a sensor will also give you an app. You don't have to go anywhere. You just take any sensor you take these days with the Bluetooth compatibility, they will give you app. But this app is very, very basic. In fact, whatever is currently going on, you will see it. Nothing more than that. You cannot have a video consultancy with the doctor. You cannot put a home diagnostic request. You cannot order medicine. You cannot do this. You cannot log your meal. You cannot. So all these things. You cannot analyze your data. You cannot see your HbA1c value. There are many things that comes with the app bundle. So when you actually spend some little bit 1,000 rupees per month or something, whatever that price is there, whatever that way, it's certainly worth it actually.
Good. Continuing, many brilliant ideas never leave laboratories. What was the hardest part of turning your research into Vishvasys Technologies, to a device a real patient could
trust? This is a question to CEO, by the way. CEO, ready? Not really, okay. All right. Okay. So hardest technology not X. It's also God is great again, I'll say that. See, the government policy, if you see, has actually taken a very good upward movement for, I don't know, I will not be very political here or whatever it is, but essentially that's a fact. So there is a lot of emphasis has been given during last decade or something for every faculty to talk about putting that research not back into library. So the knowledge should not come from library to go back to library. And we have done quite a few times actually. Right? If you tell all of us, where Anand Suresh is there, all of us have sufficient number of publications. It's not that way somebody questions us that way. So first thing is first. In fact, any young faculty that is looking at this program, probably I will recommend also that because you are a faculty, don't jump into startup. It's probably not worth it, in my view. So you establish yourself there, so people know your field, know about it, and feel sufficient confidence, experience, all that you gather. Then a lot of government support is there, incubations are there everywhere. I mean, our institute itself has 2 incubations and 2 sub-incubations. One of that is here, TCPD, TVI, that's sub-incubation. So there are some lot of support also is there. Not that you don't have to do, you still have to do many things, you still have to learn many things. It's a different world altogether. So last 2-3 years I have learned quite a few basically. So now you have to talk to one day you talk to chartered accountant, company secretary, corporate laws. Then incubator gives you some support but not every support. And then you talk about independently collecting fund generation, which we have not been successful. Then you talk about successful so far, hopefully you will be successful. But then we talk about not losing patience, where we can talk about many things, same thing again and again. And thanks to IISc and our other companies, I also there, both of them are tireless, they keep on doing that basically. Sometimes you get some recognition, there are some initiatives, something called NASCOM, okay, so that they also give recognize sometimes. They will not give you money, but because of their recognition, you may get recognized a little more. Then there are multiple ways it can spread actually. So that way. So essentially what you're talking about is all of us as scientists will always like to see our research getting into somebody's life benefit. It's either a country's pride or a people's life. That's what we call it. That is a tagline in aerospace, by the way. In aerospace, everything that we do either comes with a country's pride or people's life. Either way. Like you put a commercial aircraft, people's life. A fighter aircraft, country's pride, or Chandrayaan, country's pride. So essentially biomedical is also like that basically, right? It's a people's life essentially. So that is, so all of us have the dream that someday we'll be able to do some contribution back to the society. And whatever way we can do, we find a sniff it somewhere, then we jump into that basically. That is what happens to all of us, and not just me basically. So before retirement, we wanted to see something happening. So probably this is the right time that something ecosystem developed. And then we thought, yeah, for something we can actually take it to the people from there. But then once you started doing that and then put it back, then you realize that insulin pump takes its own time because of compliance issues and certification issues. Artificial pancreas even further. So if one artificial pancreas, if I can deliver before my retirement, which is 10-12 years away, then I think like my job is done. I'll be very happy actually. That is, we are struggling for that. Not that the engineering is difficult, engineering is more or less done. After that journey, when the TRL level goes 1, 2, 3, TRL is something called technology readiness level. We are aware of it. So when it goes 1, 2, 3, 4 like that, after 3 or 4, after 3 I will say there is nothing much research. They talk about a lot of other things that start, engineering problem, management problem, service problem, funding problem, many things are there. So when you do that, I don't know why they call technology readiness after that. Technology readiness is up to 3 only. After that it is engineering readiness, management readiness, service readiness, all that you can talk about. So once everything is done through that, and then only your product is ready for market. So that is, if our journey is successful, at least from 5-6 years from now, because already we have spent some 5-6 years already. So then we'll be very successful there. But then our company will not sustain, because 5-6 years funding will you get actually. So again I tell you a secret, getting funding as a IISc professor is much easier than getting funding as a founder of a company. I think Suresh will agree with that, right? Founder of the company, nobody bothers you. But as an IISc professor, people will come to you. The same thing that we talk about. So there is a lot of challenge in that sense basically. So then we thought, okay, something that we can generate money so that the company is self-sustainable. Then we started looking at what other people are doing around this technology. Then we came to know all these other competitors, like SugarSight and all sort of things. I thought we also can do it. In fact, we can do much better. Because our whatever we have done from aerospace inspired artificial pancreas, all this knowledge can come in here, and we can actually have certain uniqueness in our app, which others probably will match later, but right now not there. So that is how we started, and hopefully we will succeed from here.
I think we should give him a big round of applause for the tagline that he has given for aerospace, which is country's pride or people's life. I love that tagline. So today's theme is affordable technologies for mass diabetes care. How SugarSight is economically viable to all? I think our audience would want to know that.
Already, in some sense. I told you, if you really go to the price, we purposefully do not want to put a pricing part here, because we don't want to take it as a commercial thing or something like that. Pricing part is certainly available. Those of you who are interested, you can go to the stall. There is a price chart also available. In fact, there are various subscriptions. I will just summarize it because you asked it. We actually have something called monthly subscription, something like 3-month subscription, so half-yearly subscription, 1-year subscription. So 1 month is okay, monthly, you can do it. If you are not confident whether it is useful to you, not useful to you, can do that. 1 month is anyway free. By the way, our price does not include the sensor price. Sensor is separate, and also we are thinking and talking to many people to integrate many sensors, not just one sensor. So right now we are only kind of integrated that Abbott Libre 2 Plus. And then that also we are getting a discounted price base. If you go to that Amazon or wherever it is, we are almost 1,000 rupees cheaper. So whatever price you are getting, only that price will sell. Again, that is there is no profit there. Okay, that is that part. Now the question here is how do you do that, the whatever business and all that. So now talk about 3 months later. Suppose you take 3 months package. It is not 1 into 3. Whatever price you get, there is slightly more discount. Similarly, you take 6 month thing, little more discount. For 12 months, it's more discount. And because you are inaugurating or relaunching or something, there is a launch discount. So suppose some of you want to buy it today, maybe 3,000 lesser or something, you get it. Then each of you, by the way, can actually become officially our promoter. I mean, each of you don't have to subscribe our app, simply log in and you become a promoter. Then everybody can earn money. That is also there. Not only just promote our message, but because you are doing, so essentially money doesn't come to us. It goes to you as a thank you note, basically because you are promoted and things like that. And that promotion is not for 1 year only, because 1 year, first year, whatever you get, supposing that the same patient comes back next year, then whatever money you are getting as a reward, first year will get half of that, second year, third year, fourth year, it continue that way. So there is a mechanism through which actually it can be, we hope that message will spread. And then people, everybody will get benefited. Not just you are a patient, you will get benefit, you are a promoter, you will get benefit. Suppose you get a mass promoter after that, you promote many people basically. Then you get further benefit. Then you talk about, so there are many things that happen. You go to our website and they get all the details there, go download our app, there are all sorts of things. Everyone, those of you get, there's a consent sort of thing, so you get a consent tick mark, you will get a QR code. That's a unique QR code. So tell your friend that, okay, this is my QR code. If you operate through that, register through that, then if somebody does it, then it is tagged to you. And then all these accumulation will happen. Also, in our subsequent functions, will honor you. I mean, there are all sort of things there basically, right? And not only that, we are now talking about going to some sort of a campaign, in other words, awareness campaign. Go to Samavattam first maybe, so he has also agreed for that. And we'll do MS Ramaya Hospital, we will also go there that way. So we'll talk about, let's say, old age. This is very good for something called old age homes and all that, right? The geriatric care. So pediatric and geriatric, both are important actually. Pediatric because some people are pediatric diabetes, juvenile diabetes, some people are geriatric. That means old people are diabetic. So that's everything can be done through that. So we are targeting a variety of things. Those of you want to get involved, welcome. We'll talk more on that actually. But pricing details, you can get it from that side.
Final question, Professor. 10 years from now, what does success look like for diabetes care in India? And what is your one message to the young researchers who are present here, doctors and entrepreneurs in this room?
Well, first, last question first. Probably doctors, young people, right? Always we feel young. Okay. The best part of working in an academic institute is never feel old, by the way. Right? The moment the students are a little bit older, they are pushed out. Right? Right? So whoever comes in is always young. So we always feel that is one of the good part. By the way, there is also a study somewhere that people, suppose mentally you feel young, then many diseases may not come to you. I mean, there is some study basically. If you mentally you have to feel young, so you put some black hair or whatever it is of you, means also feel like feel young. Just because you are feeling young, the body will react to that way. There is a study for that basically. But that apart, the message to the young generation, including our son, daughter, whoever is watching this or listening there, you should have a lot of patience actually. That means research is a test match, it's never a T20. People think that AI will give me something, AI will do this way, that way and all. It's never a T20 game. So, there are so many things that has happened which will help you getting it faster. So we also train people like what is called ethical AI basically. So ethical AI, there are a lot of debate in IISc also, what is ethical, what is non-ethical, what you should do, what you not do and things like that. One of the strongest bottleneck of research has been literature search. Now the literature search has become global, it is language agnostic by the way. Now if there is a literature in Chinese or literature in Russian or literature in France or Italy, whatever it is, in their local language, AI not only can dig it out, it will translate it to in English and then compile all sort of things and give you a summary. I mean, remember how much time it takes. You don't even read those material, right? It will remain isolated like that. So that is a help that is very much ethical. So I tell all of this, whatever you talk about, initial literature search, is fantastic. Many topics that we teach, so suppose you talk about different topics we teach, then many times you generate, I mean, very honest here, we generate slides through AI. And then slides doesn't mean that you've done. So you select from whichever slides is applicable, amplify it, support your knowledge, and then make it customized. But it saves you a lot of things. You don't have to really study the book material and get it done basically. So that is certainly the ethical way of doing it. So literature search, which usually takes 1 year, 2 years, can be substantially reduced now. And you do a lot of things automated. Similarly, when you write a report, write a paper, you actually can generate a first draft that way. That is also ethical by the way. That's also legal. You can actually declare that in a paper that I have used so and so AI basically. So it saves a lot of time both ways, input sense, output sense. But having said that, your research should not be done by AI. Research should be also done by you, certified by you, think process, thought process, everything should go through you. And eventually, if it goes to somebody's life care, things like that, each and every code line, by the way, codes can also be generated by AI nowadays. Cloud AI, no? You can talk about generation of codes through AI. That's also possible. But that everybody should use it. If you don't use it, then you will be left out also. That's it. Especially those of us who are having startup companies and things like that. And if you adamant that I will not use AI code, then you will be left out. I mean, that is how it is. So many times you do it, but I also tell all of our company people that you can, even if you do it, for every line you are accountable. AI is not accountable. You are accountable. So essentially you learn, understand, comment, document everything, then go through that and then integrate it. So that is the process that you have to go through. So there are certain good things, that is the first part to the young generation. Have patience, take advantage of the technology, but don't be super ambitious to kind of everything that fellow does, I will not do anything. And in fact, that is a sad story. Many of the people, many of the students have gone into that psychology that, okay, I will do everything. I have to just learn how to use AI. There are training programs for that also. There are courses for that also. How to use AI, what kind of query I will get, what kind of things I will do, which I will use, what, all these things are there. But never get so dependent on that your own intelligence becomes only artificial. All intelligence becomes only artificial. So that you should prevent somewhere actually. So that is something that you should never get into basically. Once you get into it, it is addicted. It is very addictive by the way. So it will not come out it, and like a smartphone, you will become servant of that only. So that is something, that message that I give young people basically. So what's the first one, first question?
So 10 years from now.
10 years from now, okay.
What does success look like?
10 years from now, we can, whatever 10 years back I was, 10 years from now, I can just imagine a curve going up actually that way. So in other words, we just started like a hobby, now it is a very serious exercise that all of you know basically that way. Global sense also is like that actually. So it is essentially the technology is developing so fast that I will not be surprised that all our artificial research, pancreas research going obsolete actually. I will not be surprised if it happens. There are genetic studies, there are some cell culture level studies, there are many things there. By the way, how many of you probably know that the entire world becomes diabetic and entire world becomes insulin dependent, there will not be deficiency of insulin. That much is guaranteed. Now, how does that happen? That doesn't happen overnight, no? When you talk about first insulin was created from a dog, and then the Western world in US and Canada, if you kill a dog, you are killing a human by the way. So so these people are stealing dogs overnight and all that because nobody should see them. So that is happening. That story is a very fantastic journey by the way. So then came the point where dogs are not available. What do you do? They synthesize from cows because butcher shops are available. Cows have larger pancreas, all that. Then there is a biocompatibility issue that you cannot do it. So now it has gone to cell culture level actually. So it is not required. Lab will generate insulin. So killing is not required because you can multiply that and all that. You can talk about more than that way. So if I'm telling you, the entire world becomes diabetic, if there is a insulin dependent diabetes, that much insulin is available. That is the technology that we are talking about. So 10 years from now, there will be so much growth on artificial prediction part of it. We are talking a lot of prediction that will happen. Lot of delivery mechanism, whatever you are talking about will also improve. There will be implantable things. So essentially, you just put inside your body. Now we are talking outside. What you saw is outside. But there will be inside the skin. That is also there. There are some sensors there which is like a capsule level you put inside and that will stay there for about 6 months or something. It will give you a lot of parameters. So that is also there. In fact, the latest generation artificial pancreas, actually the insulin capsule goes inside your stomach and stays somewhere. Okay, so from there you start releasing. Almost like, it's already there. Italy people, there's the same group, what Dr. Basu and all that they talk about, no? Their diabetic research is a lifelong person. So they have gone to that level where you gulp an insulin pill, that will not get digested, it will stay there, and little bit, it will keep on secreting. It's almost like a inside body actually, right? So lot of fascinating things are happening. So if you really talk about technology level, yes, science level much more. Diabetes complicacy, there will be a lot of studies on that, lot of cure on that. So sky is the limit basically. So many things can happen. There is nothing that we have done everything that nothing left out, not really. There are so many things will happen, and then young generation again get excited, get passionate about. You have to really latch on to certain things and have patience for 3, 4 years, 5 years, whatever it is. Then you get some light at the end of the day that may propel you for the next level actually.
Thank you, Professor Paddy. I was just thinking, going back to your point on for the youngsters, you mentioned that don't just rely on the AI. I was just going to say that we should have such programs more often where our students can follow the learning process Shravanam, Mananam, Nididhyasa. They listen to these good concepts, they contemplate on it, and then put into practice. On that note, thank you, Professor. Your journey shows us that innovation is most meaningful when it reaches those who need it most, and that world-class engineering and compassion can live in the same laboratory. We wish Vishvasys Technologies and SugarSight every success in making diabetes care affordable, accessible, and patient-centric for every Indian. Ladies and gentlemen, Professor Radhakant Padhi, let's put our hands together.
Thank you very much.
Thank you, Dr. Archana and Professor Radhakant Padhi for that amazing fire chat. Proceeding to our next session, the second panel discussion, it is my privilege to introduce our moderator, Dr. Nibedita Rath, Scientific Director at the Open Source Pharma Foundation with nearly 2 decades of experience in drug discovery and development across academia, industry, and the non-profit sectors. Dr. Rath's work spans cancer, infectious diseases, and translational healthcare innovation. She currently leads several groundbreaking drug repurposing initiatives and AI-driven healthcare projects. Joining her on the panel are our 3 distinguished panelists. First, Dr. Siddharth Jhunjhunwala, Associate Professor in the Department of Bioengineering at the IISc, where he heads the Immunoengineering Lab. His research focuses on particle immune cell interactions, neutrophil dynamics, and the behavior of innate immune cells in diabetes. Next, Professor Anant Suresh, HAG Professor at IISc, whose pioneering research intersects mechanical engineering and healthcare to develop adaptive smart footwear technologies for diabetic patients. And Dr. Satyanarayan Srikanta, founder and medical director of Samatma, an eminent physician scientist who has served on the faculties of Harvard Medical School and AIIMS, recognized widely for his transformative contributions to diabetes care. Together, they will deliberate a critical imperative for healthcare equity, making diabetes care accessible to every Indian. I now invite our moderator, Dr. Nibedita Rath, to initiate the discussion.
Good evening, everyone. I'm sure you all must be very tired and exhausted, so we'll try to make it little crisp and short. So today's panel is on a subject that affects every Indian household in some or other way. So India has the largest burden of diabetes, and it's a growing burden also. But if you talk about access to healthcare, diagnostic, even the clinical care, it is very uneven across Indian society. So today we have 3 distinguished panelists who bring complementary perspective, starting from clinical care practice to engineering innovation, which includes screening and devices, and biomaterials for diabetic wound healing. So our goal is not to just look at the scientific challenges that we face during discovery and development, but also what is scientifically possible when you talk about affordability, accessibility, and scalable for India. So before we start the panel discussion, I would request Dr. Srikanta to just give 1 or 1.5 minutes, because he would like to give you a message to all of you, because he is in this field for decades together. So over to you, Dr. Srikant.
Namaste. I turned 70 last Diwali, and whenever I get an invitation from people like Radhakant, I become nervous. So I've done my homework as a high school student. First of all, whenever I come to this temple of science, you feel young, you feel, you receive so much information. Myself and Mala are the little 2 odd people who are doctors among scientists and engineers. First, pranams to Radhakant Padhi, Professor Navakant Bhatt, Professor Anant Suresh, Siddharth Jhunjhunwala, and Srinivas Madhusudan for the so much new information I learned and few of my colleagues learned. But the last fireside chat gave me one more insight. I'm supposed to be an endocrinologist, 50 years in this line. I think when the Tata IISc Medical School comes, Dr. Radhakant Padi is the right person to become the chairperson of endocrinology diabetes. I think he should be given all degrees, MBBS, MDFR. He has learned more than other people. But initially, there are two terms in this whole seminar which strikes me and I didn't understand, so I did some work. One is the term technology, another is the term carefree. See, in the field of medical conferences, the term diabetes technology has become fashionable. Whenever you go, they talk about sensors, automated insulin delivery algorithms, then smart insulins, not just smart pumps, smart insulins, glucose responsive insulins, now the islet-specific, antigen-specific immunotherapy. The latest is bioengineered hypoimmune islets. It was in New England Journal last week. Okay, so all this is supposed to, the biology and engineering are competing. I wanted to know what is technology. Then I realized that techno is skill, logos is knowledge. So you really realize that technology is more than software, hardware, gadgets, algorithms, etc. There is an element called humanware, where I think I can contribute a little bit today. Technology is also, when you're in a clinic, taking the patient's history, do the physical examination, the reasoning you want, and connecting the dots of the so many pieces. And I also learned talking to the patient, compassion, humility, everything is technology. So that's where I may contribute a little bit. The day is over, so I'm going to keep it short, but I'll make it a little more, hopefully, through two stories. I'll tell you two stories about being carefree. One is 1974, another is 2026. When I entered medical school, my first patient was my grandpa. He's a high school, brought us as a doctor. I studied, the house rent was 22, we lived on the floor. He never went to a hospital, never saw a doctor till 80. 80, he got diabetes. And my dad, a family doctor, used to give him 40 units of NPH. And my grandma would boil syringes and insulins in the kitchen. And my grandpa was taught how to do Benedict solution, 5 ml of blue solution, 8 drops of urine. In the toilet he used to do, and that was his care. He did well for 6 years. But there was one problem. Whenever he would take insulin, but on the day of the puja and prayer, he would delay his breakfast. And believe me, we had to take several times to the hospital, unconscious, hypoglycemic coma. But he was carefree. He was fully contented. But not a single complication. 6 years fast forward, I went to AIIMS as a postgraduate medical student. He would occasionally write a postcard to me. Something happened. He would go to the best hospital, unconscious, come back, puja days. He developed, I think, some tummy infection, and he was not well. My dad took him to my dad is ordinary GP, took him to the best hospital, best specialist, and they told, oh, this old man comes with low sugar. They put him on a drip, glucose drip, didn't check his urine sugar, didn't check his blood sugar. My dad went to see his patients. 3 hours later, he was unconscious. The best hospital in Bangalore did not check his urine glucose, did not check his blood glucose, unconscious. 6 years later, he died due to diabetic ketoacidosis. So humanware was missing. Still it was. Now, let me come back to 2026. We have an active clinic. Today, I had to cut short. It's very challenging. That is our laboratory. Now, I get most of we have a team of 18 endocrinologists. Believe me, we have a software where we have to enter which doctor referred. Do you know now the most referrals are from Dr. Sundar Pichai and Sam Altman? Okay, so we have created a field. So now what has happened? Young people come and they are called techies by the media. I didn't understand. Okay, they are techies. They come with a self-made diagnosis, 14 pages of colorful CGM report. They would have made a AI-generated diagnosis, and they will have a big list with you, highly knowledgeable, very bright. They sit in front of you. Then you talk to them, what is your blood glucose? 97, okay, it looks fine. What is your A1C? 5.8, doc, it's above normal. And then they talk about their inability to not concentrate. In one term they call work-life balance, their stress, they can't focus, their challenges. And I listen to them along with my team. I'm blessed with a large team of, do you know finally what I tell them? Hey guys, stop focusing about BG, blood glucose. So how do I end my conversation? I will refer you to another BG, that is Bhagavad Gita, Karmanyevadikaraste. March ahead in life, don't bother, you're perfectly fit, don't see doctors. And they are, okay, and he's not carefree. So technology will not assure carelessness, we need a foundation. Thank you very much.
Thank you, Dr. Srikanth. So let me start the question from this end, right? So the first question to you, Dr. Jhunjhunwala, what does making diabetic care accessible to every Indian mean to you? And this question is for all of the three panelists. And what are the biggest barriers today?
Thank you, Dr. Rath. It's a question that I think should be directed to epidemiologists and clinicians. Coming from the engineering background, I'm not best suited to answer it, but I'm just going to divide it into something saying what I've learned from other clinicians and epidemiologists. I think in India especially, we can divide it as the top 5% in terms of economic status, not even social status. There's not much that needs to be done for diabetes. I think they're doing their bit. Maybe they should not, as Dr. Srikanta pointed out, maybe not rely on their doctors, not on tech and other solutions. They will get some better inputs there. But for the 5 to 50%, I think the biggest thing that we can do in India is to get them on to regular health checkups. They can afford it to some extent. Some of it can be subsidized, but getting them health checkups on a regular basis, getting that information out there would be essential, and that's something that we miss out in India. And for the bottom 50%, I think that's where economically they're not able to even get health checkups. That's where I think policy changes and government programs at the primary health center in various areas where this technology that we have been developing and discussing could be applied, so that it can be easier to do some of these tests at their homes or at the primary health centers. And overall, the one thing I would say is just getting regular health checkups for the entire population. While there are problems with that because you might pick up things that are not necessarily bad, that's a separate problem to deal with. I think the first problem is, can you get a health checkup once in a while? Thank you.
Whenever I come across an international friend who visits India for the first time, I tell them, we are a difficult country. We are not a country, we are a continent. It's so much diversity. We have written a lot of papers on this. This question should be answered in two parts, the haves and the have-nots. Let us take the have-nots. If you come to our clinic, the ground floor is almost free subsidized. 1/3 of the pay. We run one of the largest type 1 and type 2 free clinics in the world. And the same doctor, the first floor they pay. Whatever the first floor pay, they keeps going. What do the have-nots want in the village or in some? You just have to give them some information, get their annual health checkups. You don't have to do the so-called Apollo master executive checkups. Everybody is a master executive. These are all brand names, useless. Get the simple sugar, blood pressure, cholesterol, we call A, B, C, and check it out. Tell them not to smoke, not to drink, walk around, and that is enough. So, and if they are fine, call them next year. If they have diabetes, hypertension, India has the cheapest medicines anywhere in the world. Go to Jan Aushadhi, make them available, call them up. Basic care, I think things have improved a lot. There is the government sector, the private sector. The government is doing well, much more can be done, that's not. Now let us come to the haves. I will tell you, I worked in the best centers in the US. Our boys and girls, our elderly are very smart. Today, Bangalore, Tumkur, everything, can give diabetes in healthcare as good or better than Mayo Clinic and Harvard. Our boys, all of you know, they are and our patients are very, they listen to us. They have the strong spiritual foundation. For the haves, give everything possible under the sun. Just today I had 2 young patients. One was the engineers. He has a rare monogenic type of diabetes. The Bangalore does genetic tests better than anywhere in the world. I have friends, I have one rare case where the guy who discovered that syndrome called Carney syndrome, he visited. I had sent the genetic samples. He said in Bethesda, they said mutation negative. The Bangalore picked up. So India is good. Have not should be given the best. How to bridge the gap? One small thing. One of my colleagues presented a paper in Europe about the story of haves and have-nots. I have children who poke themselves, whose blood glucose levels are as good or better than those on my artificial pump and pancreas. We called it discipline compensation of poverty. They reached so lives. At the end, the last slide was Sachin Tendulkar and I think Aishwarya Rai. We told how we are struggling to bridge the gap, and European professor said, what not, your country does so many things, why your country is not taking care? The government should give more. Now, we struggle, Karnataka is supposed to give free insulin. It has not yet been indented. I think government has to do much more for the have-nots, and the haves will manage well.
Yeah, thank you. So I think in terms of think about diabetes, it's a systemic disease. It's going to affect a lot of other. I think in terms of think about diabetes, it's a systemic disease. It's going to affect a lot of other things in the body, and complications is what we should focus, and that's where I think care should be accessible to people. And when I was doing literature search for my food project, I read that in Sweden, every person diagnosed with diabetes would have annual foot exam. Forget about retina and other things people are aware. Even feet are done. So then I thought, how do we do in India? People are not even aware that they are diabetic, even educated people in IISc. So we can think of the other population. So I think there should be a lot more to be done in terms of awareness first. And then once they're aware, diabetes is a long-term disease. So if they're aware early on, they will take care of themselves, their lifestyle and eating habits and everything. I think awareness is the key first to make it accessible.
Can I just one small thing? Awareness is not just the patient, the doctors also. There is a very good diabetologist in Nagpur called Sharad Pense. He told all of us, when a patient comes, don't shake the hand, touch the feet and start the exam. So doctors have to pay respect to the feet of their patients.
The second question for you, Dr. Srikanth. So we all know you have decade of experience providing diabetic care. And what are the most important gap that you see in Indian diabetes system, and how we can fill those gaps?
I made this simple, the first gap has been pointed out by several people is the late diagnosis. The second gap is education at all levels, patient, family and public. The third is one person cannot do. You need a team care, you need a doctor, counselor, health educator. And the fourth is lack of continuity of care and long-term care. In India, a lot of medical practice including is lettered care. If doctors scribble, we are supposed to have the worst handwriting until next visit. Now slowly EMR is creeping up, and I'm very happy that Indian Institute of Science is going to take the national AI in healthcare mission. It will try. The last is prevention versus repair. The Times of India glamorizes bypass surgeons and dialysis, but they don't talk about preventive care. Preventive care is not glamorous. Let me tell you one small thing. I came back home after 16 years wandering in US and Delhi, and I joined one of the 2 corporate hospitals. They were there. And the first thing I did after I came back is set up India's first patient education program in New Delhi and this. So we used to run classes, everything. One of my school colleagues who has become a doctor walked into my office and he told me, what has happened to you? What has happened to all your gold medals, AR1? You have taken a non-glamorous, sorry, he used the word unsexy specialty like endocrinology. You should have become a cardiologist, diabetologist, and gastroenterologist. You should do procedures. You would have been celebrity. I said, sorry, thank you very much. I'm not in repair, I'm in prevention. My diabetes educator is my endoscope. My class are my cath lab. My goal is to keep all my patients away from cardiologists, nephrologists, and what do you say, ICUs. They should live peacefully. So the attitude of doctors have to change. And think you just have to, okay, one last thing. When we do classes, patient education classes, I use a famous Chinese proverb. If you give a man a fish, you feed him for a day. If you teach a man to fish, you feed him for life. For diabetes care, the patient is the doctor, the family is the doctor. What you have to educate them, and you be a friend. So I think this is the gap we need to sensitize.
Absolutely. So awareness and education is the key to every disease, to control and prevention and care. So for you, the next question, Dr. Anand Suresh, as you already mentioned, the early screening is very important, and why the early screening in diabetic neuropathy and food risk detection, it's so important. And how can technology, we know there are certain technology present at this point of time, but how can technology also help identify patients before ulceration and before the amputation, of course?
Yeah, I think there are a lot of tools already to diagnose retinopathy, neuropathy, peripheral neuropathy. Now there are indigenously made tools also. The NeuroTouch is one of them. The monofilament test can be done very easily, and it can do the heart pulse and cold pulse and vibration, prick, everything in one handheld instrument. Similarly, ForceMat, we have Indian companies making it. What we lack at this point is ABI, TBI, that is still not like portable. That is to measure the blood pressure ratio, I'll put it, arm to the ankle, arm to the big toe. That is still expensive and it's not portable. From my discussions with clinicians, what I found out is the most important one is actually foot pulse. The doctors would take the pulse of the foot ankle region. So that can be done. If that can be done, I think that will also prevent not only peripheral neuropathy related diabetic foot ulcers, but also peripheral arterial disease. So that will be something very useful for digital health setup, because everything cannot be going to the clinic. So there are already tools coming up in India. There's need for some more. I think this diagnostic things is a moving goalpost. So we thought that we have, novel random glucose and other thing. Now we have HbA1c. While people start to afford that, now we talk about continuous glucose monitoring. I think these things will keep moving. It will never be the end. I think we should have something that is workable in India, have technology for that, rather than chasing, things that people keep moving, and focus also on the treatment rather than just diagnostics.
Absolutely. So in continuation to that question, so we know that availability of affordable tools like monofilament, as you mentioned, and turning forks and all that. What I see as an individual, so we have implementation or screening is more reactive than proactive, right, in Indian scenario. So what's your thoughts on this? And should we invest on new technology or design an effective pathway for implementation of already existing technology for the rapid diagnosis and cure?
I would say that we should not just be reactive. We have to be proactive. We have to study. I think there are a lot of people here have thought a lot about what to do about diabetes care in India. So we should sit down and think what works best for us. If we just go for what others do and then adopt it, we'll be late in the game, and we won't be able to ever catch up. So I think we should look at both diagnostics and therapeutics at the same time, and keep in mind what works in India, what people can afford, what can go everywhere throughout the country, whether haves or have-nots, everybody. So that's a generic answer in the limited time.
Okay, thank you. So, Professor Jhunjhunwala, I know your lab worked on immunomodulatory bandages for diabetes, and immunomodulation is very close to my heart because we also do a lot of late-stage clinical development. We currently finished phase 2B trial For TB, we have taken an immunomodulator, and which has worked fantastically for promoting the lung function in TB patients, And we have a couple more candidates in the immunomodulator for tuberculosis and other infectious disease. Having said that, so why immunomodulatory bandage and how it is different from the regular wound healing?
Great question. What we have come to realize is that some, if not many, of the complications of diabetes are driven by changes in three things. Two well known, which is lack of blood vessel growth, which is what happens in macrovascular changes to microvascular changes, and also neuropathic changes. These are the two major ones. The third one that has picked up, and a lot of people have recognized it, is immune dysfunction. Increased blood sugar levels in the body systemically for long periods of time affects many of the immune cell functions. And what we were able to do using a clinical study was to identify that immune cells are changed in individuals who have diabetic foot ulcers, especially those who don't heal their ulcers. Some of them are more inflammatory. So while your standard bandages that are in use today would work very well, assuming everybody is at the same level of potential healing, if the immune cells are inflamed in one individual and less inflamed in another individual, that same bandage will not work. And in that context is where we were coming up with these immunomodulatory bandages, which is in individuals who have higher levels of inflammation, use the immunomodulatory bandages. And in those who we can measure and say that the inflammation levels are normal or low, then we don't need these immunomodulatory bandages.
Thank you. I think we are running short of time. So my last questions to Dr. Srikanth. So how we can make quality diabetic care affordable and widely accessible across India? But before I say that, so as an organization, what we do to make treatments affordable, you widely focus on repurposing of generic drugs. So that is our primary focus. And we have been trying and we have been successful in a couple of trials. We are going into phase 3. So Dr. Srikanth, in diabetic care, how we can make things affordable and accessible for Indian patient population?
It's not an easy question. The government, the private sector, the private-public partnership, everybody has to chip in. As I sit here, do you know we supply insulin to about 5,000 children all over? Do you know where I get my donation from? From Australia, from an endocrinologist who is a Christian pastor, he sends. We have to sensitize the public philanthropy, but government has to play a major role. Now, as far as diabetes, Karnataka has told that they will give an insulin. One question, there was a lot of discussion on technology. If I look back, I will ask, what is the simplest device in diabetes? It is the blood glucose meter. It was discovered some 50, 60 years ago. Okay, when I left this country, India had only one blood glucose meter in AIIMS, 1981, and nobody was allowed to touch. When I came back in 94 to Bangalore, even the Malya Manipal hospital were dipsticks. Why India could not deliver a blood glucose meter when we boast of BrahMos, Tejas light compact aircraft, and so many landing on the moon, etc. Think over. To make that affordable, there were few things needed. First was Indian Institute of Science. Second was one of the scientists among you, Professor Navakant Bhatt, with his humility and drive. And number 3 is the path showed. So what you all are doing is the most crucial one. I hope you have realized till Navakant got this POC, not a single Indian government or private agency ever bothered to get a small blood glucose meter. In everywhere China has taken over. Now the Abbott Libre is being out. Lynx Chinese, they are flooding the market. The latest artificial pancreas microtech is this. I can tell you, I feel sad when I see why China is doing, why India is doing. I think everybody has to introspect. Something wrong in our system. We need more Indian Institute of Science. Every time I come to this great temple, I go back with a silent prayer. I will tell you openly today. Before God takes me, I want 5 Nobel Prizes from this Indian institute. There are people, the government has increased your grants by 100%. Means we are forced to put money on bombs, everything. It has to come to science and education. That is the only solution, madam.
Absolutely, absolutely right you are. So one of the main question, I don't want to halt our discussion without knowing one important thing, and this is the question for you, Dr. Jhunjhunwala. So what are the main challenges in translating the discovery? So just let's focus on your biomaterial-based wound dressing from lab to the clinic or the bedside.
There are many. I think there's some very good startups that you saw stalls off, and they are trying to make that change. So one of the first things is even just within my lab, within my own research group, the idea of taking it beyond the lab, right, which is the big question. And a lot of us have interest, as Dr. Shrikanta pointed out, we have to introspect on that beyond publishing papers, beyond doing that. So that's our, as a professor, as a researcher, that's a part that we need to do better. But there are other aspects to this that also need to play a role. I feel that for translating technologies, one of the biggest challenges has been to identify finally a business and a market, which is not the same as the science. Your science may be very good, but if the market is not very good, or you have not done your business strategy well enough, you're not going to succeed. And that's a very different mindset. It's a very different thought process. And so getting more people who have the business mindset into the scientific community could help in that translation. Finally, I think it is overall increase in funding throughout the process, and not just at the end, which is only translation, but also some of the basic research remains to be done, and some of the products fail because the initial research was not done well enough, and so money throughout the system from basic research all the way to translational research.
Okay, thank you. So we have one rapid fire. I would like my panelists to just answer in one word or one sentence, not more than that. So it won't take much time. So one low-cost intervention that can immediately improve the diabetes outcome, Dr. Srikant.
I would choose patient and family and public health education and empowerment. That is the fundamental.
Exact same thing, educating the population, family and people.
Since they both have said awareness related, I would say focusing on the feet, everybody's feet should be checked frequently.
Absolutely. One message every person with diabetes should hear. Dr. Jhunjhunwala.
Eat less sugar.
Okay, the power of prevention, learn and march ahead.
I heard it from a nurse at KIR hospital, again focusing on the feet. Treat your feet like you treat your face.
Okay. One message every family of a diabetic patient should hear. Dr. Jhunjhunwala.
Focusing on the same thing, tell people who have diabetes to eat less sugar.
Okay. Conquer diabetes and associated health challenges together with technology and compassion. You all share not just the genes, you share your kitchen behavior celebrations. It's a family issue.
I would say don't worry too much. If everybody is going to have, we'll all be together.
Okay, the last question, rapid fire question for my team. One thing policymakers should prioritize. Dr. Srikant.
I thought a little bit about it, and I'm going to share, many of you know, the words of Lao Tzu. To lead people, walk besides them. To lead people, walk behind them. A true leader is invisible. So for all leaders, all of us, from politician Modi ji to the last person, lead by honesty, humility, sacrifice, and one term called unconditional love for humanity. Why all these scientists are giving their life? They could have a cushy time. They are all doing it because their unconditional love to humanity. And that term was given to me by Honorable Padma Vibhushan M.N. Venkatachalai, the former Chief Justice. Every time he remembers, you have unconditional love, project will succeed. Everything will succeed.
Yeah, I would say that policymakers should trust researchers more, Indian researchers, that they can do everything.
I think I'd mirror what Professor Suresh said. Trust the research, trust the researchers so that policies can be made to match with the science.
So one thing I would like to reflect upon, I would like to also know from the audience, do you have an Indian policy for diabetes? As far as I know, there is no Indian policy just for diabetes, but we have a policy called NPCDCS, which is for cancer, diabetes, cardiovascular disease, and stroke. So I would be happy to see if the Indian Institute of Science, you guys are doing so much of work in diabetics, so much of innovation, then why not you all come together and draft a national policy for diabetes? They will use it. See, policy are for use and policy are for the society. So I'm sure once the policy is in place, you'll have also the society to use it and implement it, you know. So definitely, this is something I would request scientists from Indian Institute of Science to draft a policy and take the leadership in this. So now we have come to an end, but a lot of questions are unanswered, but here we are talking about affordability and accessibility. And when you talk about accessibility, it comes whether something is affordable. If something is affordable, then it is accessible eventually. So the key message is clear. So India must move from the late treatment of complications to early detection, prevention, and affordable long-term care, and also towards drafting a national policy for diabetes. Thank you, everyone. Is there any question from audience? Maybe for my panelists? No? Okay, there is one question. Okay, just one question. Yeah.
I would like to ask, how do you see gut microbiome and nutrition plays a role in diabetic prevention and management? Because this is one of the most, neglected thing. I'm a scientist, I'm a food scientist myself, being in the industry for 20 years. I've attended many DTech conference and many other conference where we forget is the role of a simple kitchen, simple nutrition. How do you see as a scientist and
the science and research on gut microbiome is expanding. It has not come into the mainstream medicine. It has gone to high funda, longevity clinics, etc. It's true, it's gone even drugs like metformin, one of the mechanisms is to gut microbiota. But IISc has got a center of excellence in Ayurveda. Okay. They do the panchakarma, the virechana, everything. All that has a scientific meaning. There are a lot of researchers working on it. It is going to be there and it will be there. It's an Indian ancient science. It has to be rediscovered and implemented.
Do you see it coming in next 5 years?
It should come. Already people, you see the websites, though it's not part of the guideline, people are getting all this cleansing therapy. It has to be put in a, it is now a Bollywood fashion, high-end thing. It should be cut in the man. The Ayurvedic science is already doing it, but it has to be proved. The studies have gone on through this institution.
These people are studying about causes, diagnosis, prevention, equipment and all that. Nobody is attacking what is secondary effects of these diabetes. There are so many secondary effects of diabetes. Why they are not studying that? Hearing loss, factors, giddiness factors, all secondary effects. Who has studied on this?
Doctor is focusing on food care. Yeah, agreed.
Actually, we have seen only, yeah. Right, yeah. Yeah, in fact, many colleagues are working on different aspects of it. In fact, diabetes, cancer, breast cancer relation, all kinds of things, and secondary effects also. Because I said diabetes systemic disease, there are several faculty are working on different things, and some have reached a stage that we see here, but a lot of work is going on. Your question is very valid.
Yeah, actually, you are right.
Thank you, everyone. Sorry to interrupt. I think we are running out of time. I know many of you have questions. Our panelists and our moderator will be in the foyer area. You can ask your questions then. I'm sorry, ma'am. I know you wanted to conclude. If you want to quickly do it in a minute, then I would probably request.
one thing is when there is a diabetes, the immunity is compromised, right? And that's why you are prone to a lot of other diseases. So in fact, you talk about tuberculosis. We have seen type 2 diabetic patients are getting more tuberculosis, right? But then this is maybe a discussion for another day. So I'm just trying to say that type 2 diabetes can lead to other diseases also. Yeah.
Wonderful thought-provoking discussions happen during this panel discussion. Thank you so much. Thank you, ma'am, for conducting this panel discussion very smoothly. I would like to request our volunteers to come on stage, and as a token of appreciation, we would like to pass on the mementos. I would request Professor Padi to come on the stage as well. Firstly, Dr. S. Shrikanta. Thank you so much, sir, for being here. Professor G.K. Anand Suresh. Professor Siddhartha Junjunwala. Last but not the least, our moderator, Dr. Nibedita Rath. Thank you so much, ma'am. Now I would request Anu to come over and give vote of thanks. Thank you.
Distinguished dignitaries, esteemed faculty members, panelists, industry leaders, students, and all participants, we hope you had a fantastic afternoon and thoroughly enjoyed the experience. I am Anushri, an undergraduate student of Biotech Engineering in the Ramaya Institute of Technologies. On behalf of IISc and the organizing team of VTPL, it is my privilege to propose the formal vote of thanks. I extend our heartfelt gratitude to our chief guest, the Honorable former Chief Minister of Karnataka, Shri B.S. Yediyurappa sir, for taking time from his busy schedule to grace this occasion for sharing his valuable vision for future of healthcare in our state. Our sincere thanks also goes to the guest of honor, the Honorable Health Minister of Karnataka, U.T. Khadar sir, for agreeing to come and grace the occasion. However, we understand his extreme busy schedule for which he could not come. Nevertheless, our heartfelt gratitude goes to him. We extend our sincere gratitude to Shri G. Mariswamy, President of the Bangalore Urban Zilla Panchayat, for gracing this event with his presence. We truly appreciate you for taking your time and coming here to join us today. We are deeply grateful to the leadership of Indian Institute of Science for facilitating the host of this event in prestigious institution. Our sincere appreciation goes to the Director, Registrar, PRO, and Joint Registrar, Deans, Security Officer, and all others who supported us from the admin side. We owe a special debt of gratitude to our eminent speakers, Professor G.K. Anand Suresh, Professor Navkant Bhatt, Professor Siddharth Junjunwala for gracing our podium and imparting their transformative insight with us today. A sincere thank you to all our panelists comprising our session speakers and our invited clinical experts, Dr. Mala Dharmalingam, Dr. S. Shrikanta, Dr. Vinay Chauhan, as well as our moderators, Dr. K. Srinivas Madhusudan, Dr. Nibedita Rath. Your collective insights and brilliant navigation made the panel discussion a definitive highlight of today's program. We also recognize the master of our program, Dr. Archana MS, for anchoring today's event so masterfully and ensuring our proceedings flowed with absolute precision and grace. Our deepest appreciation goes to the dedicated student volunteers from IISc and MSRIT, alongside our secretarial staff, Ms. Soumya and Mr. Sanjay. Your hard work across hospitality, logistics, and stage management ensured the flawless execution of this event. While your dedication often goes unnoticed, it is the true foundation of today's success. Furthermore, we extend our heartfelt thanks to the employees of VTPL who work tirelessly day and night behind the scenes to ensure the grand success of this gathering. We are equally grateful to all our participants, both in person and online. Your enthusiastic presence, thoughtful questions, and active engagement led to the grand success of this event. We are grateful to all our partners, supporters, and everyone who contributed directly and indirectly to make this event a grand success. May today's collaboration become tomorrow's solutions, and today's vision help build a future where no individual suffers because quality healthcare is beyond reach. With hearts full of gratitude, renewed hope, and shared commitment to innovation, we thank each one of you again, present both online and offline, for making this event a resounding success. We look forward to welcoming you at our future initiatives. Before we officially close, I want to extend a special word of appreciation to the true architect, motivator, and founder of VTPL, Professor Radhakant Padhi. His tireless efforts and vision behind the scenes are the reason we are gathered here today. Let us give him a round of applause. With that, I invite everyone present here to join in the lobby for the high tea. I request all of you to join us at the high tea. Thank you for your time, your passion, your presence. Have a wonderful evening, everyone.